Now we're going to go over some definitions that we'll need to know before we get into the actual technologies. We need to know the definitions to understand what the technologies are actually carrying out. So the common terms that are used in access control would be subject and object. A subject is something that is actively trying to access something. So the subject is something that's actively doing something, trying to actually make an access call. The object is something that's passive, that's being accessed. Now, can something be a subject and an object? It can. For example, let's say I'm accessing an application. Then I'm a subject, the application's the object. Now that application may need to make a call to a back-end database. In that situation, the application is the subject and the back-end database is the object. So these are common terms in access control and a lot of the literature that you could read. And what access control is really all about is controlling what subjects can access what objects and what type of operations and commands they can carry out. So in the first domain we went through that there's different types of categories for controls. That would be administrative, physical, and technical. And so we have specific types of controls that fall into these categories that have to do directly with access control. So in physical examples would be locks, removing maybe CDs, the CD drives in somebody's computer so that they can't take sensitive data away. There's software and tools today that when you put it on like a workstation, it won't allow somebody to move data to their USB ports or to write it to their CD-ROMs. Other physical access control could be that you actually lock down the computer. Years ago we had problems where people would be stealing memory and stealing processors and such, but these days those prices have gone so low we don't usually have that type of an issue. And of course there's technical controls for access control. The big one is encryption, and we have a whole domain on cryptography that we're going to talk about. But encryption's a commonly used one to control sensitive data, passwords, biometrics, operating systems, databases. They all have their own type of technical controls to make sure that whoever's trying to access some type of data, they're the ones who are supposed to be. And then administrative controls. We went through most of the administrative controls in Domain 1 in security practices. So the administrative controls would be like policies and awareness and risk management and those types of things. And these all have to work together to be able to control the access to the company's assets. Now, where there's 3 different categories for controls, there's actually different services that these controls can carry out. They could be preventative. You're trying to prevent something bad from taking place. So that's maybe why you put a firewall in place, or you write a policy. These are preventative in nature. You're trying to prevent something bad from taking place. Another one would be detective. Detective is after the fact. Something happened, and then you have to have some type of tool to gather the data to figure out what happened. So a detective could be like an IDS or reviewing logs. Then there's corrective. There are corrective controls. For example, if let's say a workstation got a virus, antivirus software can be configured to actually clean that file. That would be corrective. It's correcting the file and removing the virus information from it. Now, deterrent is another example. And deterrent means that you're trying to deter or tell somebody, look, we're serious about our security, so don't even try to break in here. And some people have a problem distinguishing between like preventative and deterrent. A deterrent is specifically so somebody knows and somebody sees that you're serious and you're trying to say, look, go move on to an easier target. For example, like a beware of dog, that's a deterrent. Or some companies have like fences and a guard shack out front, And there's no guards in there. There never has been. But that guard shack has been there specifically to be a deterrent so people think that they can't come directly in. Another service that controls can provide is recovery. So after something bad happened, they recover. Maybe the data got corrupted and you need to use your backup data, those types of things. And then the last type of control is compensation or compensating control. And a lot of people have a hard time understanding really what this is. These types of controls are alternate. They're, say, for example, you did your, you found the risks, you found your vulnerabilities, and you have, let's say you need security guards. We figured that that's what we need, is security guards to protect our environment. But security guards are really expensive. And you did a cost-benefit analysis, and you figured out that security guards actually cost more than the potential loss. So you come up with another type of a control, compensation for that one. And so then you would buy something cheaper like locks or fences or something like that. So that's very common, is where you think about one type of control that needs to be put in place to provide some type of protection, but either it costs too much, the countermeasure costs too much, or that countermeasure can actually interrupt business functions, so you can't use that type of countermeasure. You have to go to another way. And that's a compensating control, when you have to go to like the secondary alternate control. Now, these are broken down, and you're going to have to not only understand the combinations of like preventative administrative, preventative physical, but you're going to have to know examples. And what I have found when I teach this is people will see these examples and they'll read them on slides or read them in a book, and they're like, yeah, that's simple, that's no big deal. But what you have to realize is that you're going to get a question on just one of them pulled out. When they're all listed, when all the controls are listed with a headline, it makes a lot of sense. But if you get one of those pulled out, is it actually a recovery control? Is it a detective control? Is it administrative? Is it physical? So don't just blow that off. You really need to pay attention, because you're going to get some questions that could be tricky about concepts that are actually pretty easy. So some examples of preventive administrative would be policies. You develop policies, so you're trying to prevent people from doing the wrong thing. You're providing direction for the actual overall security program in the environment. The hiring practices, you're trying to prevent from getting bad people in. Security awareness, you're trying to prevent from the users not doing what they're supposed to. Separation of duties. Now, how do you think separation of duties is a preventive control? Well, separation of duties means that you take one task that's critical to the company and you split it up, and not just one person can carry out this critical task. So what you're trying to do is you're trying to prevent fraud. You take a critical task, you split it up so that one person can't carry out fraudulent activity and no one else knows about it. You're actually going to see separation of duties a few times in the different domains, because it's hit pretty hard on the exam, but it's also becoming much more important within the industry. So preventive physical, we're trying to prevent something bad. We have physical controls for that. Like I said, to remove the CD-ROM so somebody can't steal sensitive data, locking the computers, fences, locks, man traps. A lot of those things we're actually going to talk about when we go into the physical security domain. And technical, these again aren't too difficult. You're trying to prevent something by using technical controls. Smart cards, so somebody has to authenticate before they can access. Callback systems, which means that if you're remote, you're calling into an access server, and it will drop the line and call you back to make sure you are who you say you are. It's part of the authentication. So along with preventive controls that you need to know about. There's also detective controls. And again, it's a combination. There's administrative detective, there's technical detective, and physical detective. So administrative detective, the use of auditors, that would be administrative, which is not auditing. Remember in this exam, when it says auditing, that means actually logs are being created from like an application or a database. Using auditors means that an actual auditor is coming around to check and make sure everybody's doing what they're supposed to be doing. That's an administrative control. And it's detective because it's after the fact. They are checking after, practices are already going on. Inspections. Now job rotation. How do you think job rotation would be an administrative detective control? Well, and for a security reason, we use job rotation because somebody could be in one position for years and they could be carrying out fraud and we don't know about it. So we want to make sure in the critical positions within an organization that we actually don't allow somebody to stay in that position for a long time. We rotate somebody else in. And this happens a lot within the financial world, the financial institutions, where somebody who is, doing some type of transactions or overseeing accounts, they will have somebody in that job, and then after, maybe 4 months, somebody else goes into that job. And the goal is that maybe that second person is going to uncover some fraud that's going on that the company doesn't know about. Now, something similar is called mandatory vacations. And again, it usually happens in the financial sector where people who are in critical positions have to take their vacation, and it usually is that they have to be gone for 2 weeks because you need to rotate somebody in there and give them long enough to figure out what this position is, what it's all about. And the goal of the mandatory vacations, again, is to uncover if any fraudulent activity is going on. So we have technical detective controls. Remember, detective is after the fact. So that's IDS, intrusion detection systems, detect something, an attack after it's taken place. Forensics, that of course is after some type of incident took place. So you again will need to know the categories of administrative, technical, and physical controls, and then the types of services that those different controls provide, and then the actual combination. Is this something that's detective? Okay, it is. Is it physical, administrative, or technical? So it sounds easy, but the questions will be more difficult. Now, one of the most difficult things in access control is actually managing the access control. Creating the accounts, assigning permissions and privileges, but then managing its whole life cycle. And we're going to get a little bit deeper into that where we talk about identity management. But a lot of environments have accounts that the people have quit, and they're called orphan accounts that are not being used anymore. Attackers love that because they can find out the credentials for that account and work as a legitimate user, and no one would know. And also, we give everybody too much access. Almost every organization each user has too much access because it's hard to determine. Fred, does he need access to the file server? Well, what does he need to have? Read, write, modify. What about the printer? What about this? What about that? So it's difficult to actually figure out exactly what level of access each user account needs, and that's why identity management is really becoming big in the industry, and why it's on the CISSP exam. And we'll get into that in this domain. Now, another difficulty is that it's not just user accounts on an operating system that you have to worry about, but there's user accounts on databases, applications, different platforms, the mainframe, and each one of them all need different permissions and access levels. So Our environment is very complex with the level of the type of software that we have out there, but all the users who need to access different things to keep track of that properly is pretty difficult. Again, why identity management is becoming more important in the industry. So one of a best practice thing to do is that when you get a new employee, they need to read the policy and understand what they're supposed to do as it pertains to the company assets and information. They should go through some type of security awareness training, and then it's best if you actually have them sign a document stating, yes, I've read the policy, or yes, I've gone through security awareness, because that gives you legal protection. If the user does something that they're not supposed to with your critical data, they can't come back and say they didn't know. And there's a lot of cases where the actual employee, the fired employee, won because the company did not do what it was supposed to do. So it's a good practice is after you tell somebody they go through a class or they read the policy that they actually have to sign saying that they understand. Now, authorization creep is, we talked a little bit about it in Domain 1, and it's very common. It's where somebody starts at a company and they get a promotion or they move to another department and they get more resources, more access to resources, more privileges, more permissions, and nobody goes back and figures out, well, she doesn't need access to this payroll system anymore because she's in this new department. Usually, they keep on adding permissions and rights so the user can carry out their functionality. So authorization creep is very common, which just means that somebody is continually getting more access and privileges over time, and administrators or a security person is not going back over to make sure this person only has the permissions and access they need. That's least privilege. So accountability is, of course, very important with access control. We need to hold the individuals accountable for their actions, and you can't do that if everybody is called user 1, if everybody uses the ID user 1, or if let's say 20 people use bank teller 1, then when activities are logged, you don't know who actually did it because that user ID is not unique to the individual. And it sounds very simplistic. A lot of the stuff is like, well, of course, but it gets difficult not necessarily in the newer technology, but a lot of the older technology, or when you have to communicate with a mainframe or something. Once you dig into an enterprise, you'll actually see that there's accounts that like everybody uses that has the same ID, the same password, and you wouldn't notice that unless you actually took the time and figured out all the accounts within the environment. So the regulations are requiring that there's more accountability for the individual users. So we have to make sure that we have unique IDs, the logs are actually being kept, and the logs are being protected. Now, when we're talking about accountability, we need to ensure that there's a trusted path. And what a trusted path means is that nobody can actually carry out like a man-in-the-middle attack. Somebody cannot hijack a connection. So, for example, let's say that I'm communicating to a server, I'm accessing files, I'm carrying out operations, and if somebody's actually able to get in between myself and the server, that would be a man-in-the-middle attack, and they would spoof my address or act as though they're me and then carry out activities, it would seem as though I could be doing bad things because I initiated the connection, and this person, this hacker, is using my ID. Now, if somebody came and questioned, why did you do this? Why did you steal this information? What would happen is, if it went to court, you would have to prove that the company actually provided a trusted path, meaning that nobody could have got in there, which would mean that only I would actually be able to carry out that activity. So a trusted path means that There is no way for some type of man in the middle or somebody to be able to take over that session. Now, this I'm talking about like communication between a workstation and a server. Within an operating system, we will actually get into operating systems, how they're built, and talk about processes and such. But there needs to be a trusted path between the user and the security kernel. So when you actually, let's say in a Windows system, you do Control-Alt-Delete and you're going to put in your username and password. Now, if I'm an attacker, I can create a page that looks just like your login page. So you put in your username and password, so my software has grabbed your credentials and then it closes out. And then the real login screen comes up, and you think you just put your password in incorrectly. You type it back in, and then you get into your system. That's an example of there's not a trusted path between the user and the security kernel. And where this really comes into play is when systems have to be used in very secure environments. When we talk about the Orange Book and the common criteria, we're going to look at how systems are tested and what types of flaws can be allowed or not allowed. When you need a more secure system, then you can't have paths like these that could be interrupted. A Windows path or a Windows system or something that doesn't provide as much protection, there are capabilities for this to take place. So there's a lot of ways that you could be fooled about a trusted path of what you're communicating with. And this is very common on the internet. Over years, people have created websites that look just like the website that you're used to going to, or just looks just like the login screen that you use to access your account for online banking or something. So this is not a trusted path. If something can gather your information, you are not actually talking to the server or the service that you think you are. And again, this is nothing new. Users actually have to become more aware. A lot of online banking sites have been duplicated, and if you look at the actual URL, it's not the right URL. So you need to make sure that when you're logging on, you're providing credentials or some type of sensitive data, that you're actually communicating with the other server or the right server by looking at the URL. And even there were attacks that were where people could have really like a graphic over that URL, so it still seems like it would look to you like it's the right page. In those cases, you would need to retype the address in. But those are more hacking types of things. For the CISSP, what you need to understand is a trusted path, which is something that can't be circumvented. Now we're going to look at identification, authentication, authorization, and the different types of technologies used to provide this service for environments, and different types of access control methods. As always, the terminology needs to be understood. The difference between identification, authentication, authorization. So identification is who are you? And this is, you provide some type of publicly known value. Maybe the first letter of your first name and your last name, or maybe there's some type of number that's been assigned to you. But people could know about the identification. That's not the secret part of the credential. The part that is secret is the authorization. I'm sorry, the secret part is the authentication, because the authentication piece is actually proving the identification piece. You know, if I say that I'm Sean Harris, I'm logging into something and I say I'm Sean Harris, well, the system isn't going to just believe that. I have to provide something to prove, yeah, I am Sean Harris. So that could be a password, use of biometrics, a smart card, something like that. So once a subject is identified and authenticated, then they'll be authorized. Authorized means what can you access? What can you actually do to the objects within the environment. So, and these all, of course, work together. And the authorization will have, how that's carried out is there's some type of permissions or ACLs or something on the object to determine what you can do to it. And we talked about accountability, which is becoming more important in the industry, as I mentioned, but it's also more important on the CISSP exam, because they used to just cover identification, authentication, and authorization, but now they've included accountability within this section and in this domain. So identification. This is publicly available known information usually. Like I said, maybe your first name, first initial of your first name and then your last name. But what's important is that you don't have a descriptive value that describes what you do in the company. So I shouldn't have a user ID that says, payroll administrator or a network administrator or something, because if that information is descriptive about the user account, then that tells the bad guy that's a powerful account. I want to get that. So the actual what's used for identification should not be describe what that user can actually carry out. So authentication mechanisms. We're going to talk about the technologies that provide authentication, which is proving identification, and there's different categories. It could be something that you know, password, PIN number, account number, something that you have, a smart card, a memory card, a token. What about something that you are? Does that mean if you're a moron or if you're a Republican or you're a Democrat, you can be, you can access? No, something that you are is some type of physical attribute. So that's a biometric. So we're going to go through the actual technologies and see how they work together. Now, something that you do need to know about is what's called strong authentication. And strong authentication means that there's two of the authentication types that I just talked about. So you'll have an identification, and then you have two authentications. So there's identification, Sean Harris, and then there's authentication, which maybe I have a smart card and a PIN number. That's something that I have, something that I know. Maybe there's a smart card and a biometric. That's something that I have and something that I am. So strong authentication just means that there's actually two pieces for the authentication piece that has to happen correctly before somebody is authorized to have any access. Now, if this is new to you, some of the students have kind of fought back with me and said, well, strong authentication, I'm providing two pieces of information, my username and my password. That's two things, but that's not two authentication things. That's one identification thing that could be known by people, and then you have to have two authentication components. And this is interesting, like within the banking world right now, there's been rules that have come down for online banking that users have to use strong authentication. What that means is that the banks that are providing the online banking service can't just use like a username and password anymore because they've been broken too much. Too many hackers have actually got into online banking. So now anybody who's providing this type of service has to do strong authentication. So some banks are sending out like IDs, security tokens that they'll have to use, some looking at biometrics. And so it's extra cost and it's harder for the user, but it's all about security because there's been too many breaches. I talked a little bit about separation of duties, and again, this is something that CISSP hits over and over again. It's not just the term that you need to know the definition, which is separating a critical task into two components so one person can't carry out fraud. You're also going to need to know examples of separation of duties, cognitively how they would work within an environment. And the reason that it's something that prevents fraud or tries to prevent fraud is that if you split a critical task between two people, then if this person wants to carry out fraud, he has to convince this person also. and that reduces the amount of fraud that will take place. So one person, yeah, they might be tempted to carry out fraud, but if they have to get somebody else in on the game, that's called collusion. Collusion is when two or more people work together to carry out fraudulent activities. So you'll see different examples through the different domains. When we get into cryptography, we'll talk about key recovery, because you don't want, like an administrator, just to be able to recover somebody's private key. Security versus operations, there should be a delineation between what the security team does and what the operations and network people do. You do not want, it should not be set up where the security administrator goes directly to the network administrator. There should be clear lines of responsibility. So you have a security administrator that goes like up to the CISO, and then you have a network administrator that may go to the CIO. The reason is because they don't have the same, there could be conflicts of interest there. The network administrator's responsibility is making sure that everything's always up, always running. And security is not about always up and always running. So we'll see that again when we get into operations about that issue. And testing and production environments, when we talk about programmers, the programmers should not have access to any code that's actually in production, and nobody in operations should have access to any source code that's being worked on by the programmers, because they could, people could tinker with things, and that's happened. Manipulate some type of code so they can carry out fraud. Separation of duties it's not a hard concept to understand, but to actually implement it is difficult within companies. It means that you have to understand the business processes. How do we do something? And where can one person carry out too much that they're not supposed to? Where's our risk there? So the company actually has to understand how a process takes place, and then where there can actually be fraud that takes place, and then split those up between two entities. It could be two people or two departments. So like, you can't have somebody who puts in a purchase order and approves that purchase order. You have to split those up. That's a simple example, and for the CISSP exam, you need to know what I've talked about for separation of duties up to now. But in the real world, when you're not just taking an exam, this can get very complicated, and it's one thing that a lot of companies are struggling with, and more products are actually providing separation of duties functionality, because it's very hard to do manually. Now, I said that there's different type of authentication mechanisms and technologies that we're going to go through. So we're going to look at biometrics, the different types of biometrics, token devices that create one-time passwords, memory and smart cards, and a little bit about cryptography keys, even though we're going to kind of pass over that because we have a whole domain on that. So the first thing we'll look at is biometrics, and biometrics is a technology that's been around for a long, long time, and the industry has kind of been waiting for years for it to come, make its own, just like PKI. Next year is going to be the one for PKI. The next year is going to be the one for PKI. And the same thing happened with biometrics. We thought next year it's going to become more important. Next year the industry is going to want it more. And a lot of biometrics company came and went waiting for that boom. But of course, it was really after September 11th that biometrics really started to get more interesting and more used within the industry. So, because it's hard to move from something cheap like passwords to something more expensive and complex like biometrics. And users, we don't like it as much. It's in our space, it's too personal. But we're getting more and more used to it because we have to provide the necessary level of protection that's required. So with biometrics, there's some type of a reader, there's a scanning device. So you will put, if it's a finger scan, you'll put your finger in there. If it's a palm scan, if it's an iris, there's some type of reader, and it's going to collect the data from that body part and put it in a back-end database. So basically what happens is you go through an enroll process just like any type of user account that's being set up. So if you're used to how user accounts are set up, passwords are assigned, it's really the same thing. There's a user account that's set up on some type of authentication database, and then the user is asked to put, let's say, their finger in the reader. And during the enrollment process, the user will be asked to do that a few times so the reader can get an actual very good read on the information. And it takes different vectors on the fingerprint and takes that into a binary, puts it into a binary format. And it depends on the biometric tool. It may encrypt or it may do a hash, but it's not going to go over necessarily in that binary format directly back to the authentication server. So it's going to take the information from your finger, different vectors. It'll put it into a mathematical formula or into binary, and then it can encrypt it and send it back to the authentication database. So once you do your enrollment process, and when you need to then authenticate into your system, there's a process for your identity to be verified. Remember, the identity is some type of publicly known information. So if I put in S. Harris, I have to prove my identity, and that's what authentication is about. So I will put my finger in the reader. The reader's going to take the same points. It's going to put it into the binary format, and it's going to compare to what's in the back-end database to see if they match or not. Now, they don't have to match 100%. It depends upon the level of sensitivity of your biometric system, because a biometric system, you actually calibrate it to the sensitivity level needed within your environment. If you were in a high stakes, high secure environment, NSA with top secret, you may require 100% that this actually has to match. But most environments, it's a lower calibration. So a biometric can be a physiological trait like your fingerprint, your iris, your retina, or it could be behavioral like your voice print or how you sign your name. So it could be either one, physiological or behavioral. So why do we think biometrics are so great? Well, they provide more security compared to things you could lose, like a smart card or a token. Those could be lost, they could be stolen, and they could be duplicated. It's really hard to duplicate like your fingerprint. And it can't be guessed, like passwords. Passwords can be guessed, they could be forgotten. You're not going to forget your iris pattern. So they provide more security than the other things other type of authentication mechanisms we have out there. But of course, they're more expensive usually, and they're more complex. So a lot of people, have to get used to these types of this type of authentication. Society is getting better about it, but again, it's in our personal space, and we're using it. Like Homeland Security is using it to try to identify known or suspected terrorists. Biometrics can actually be used for verification or identification. And if you're using biometrics as a verification, that means you're already providing identity. So you're saying Sean Harris, and then you're providing biometrics, which proves the identity. And that's called a one-to-one. It's one-to-one because I'm going to provide that biometric information, and there's a match in the database already. If they match, that's a one-to-one, and that verifies my identity so I could be authenticated. Now, a different way of using biometrics would be identification. And that would be, it's called a one-to-many or one-to-n. And that would, like for example, at a crime scene, when they pick up fingerprints, they don't know who that is. So they take that fingerprint and they run it through a whole database of fingerprints until they get a match. That's how biometrics could be used for identification. we usually use it for verification within an enterprise, or if you're using biometrics externally to be able to get into an environment, then it could be used for identification. So one of the common ways to use biometrics is the actual iris sampling. And the iris is the color portion that's around the pupil, and everybody has a unique pattern. You know, there's little lines and there's little specks. There's a camera that you actually just glance at, and it will look at your iris. It will take specific points on your iris, just like it does, you know, it would take points on your finger, and it takes that information and puts it into a binary format and will keep it in the back-end database. Finger scan, we talked about, that's really one of the more common ones because it's easier. You know, we have laptops that come out now that to authenticate, you just provide the finger scan. These are being used more even in the military. When military people now, instead for their ID card, they have smart cards that has a biometric template in it that holds their fingerprint or finger scan. So like I said, when you put your finger into the scan or into the reader, it's going to look at different points. And it depends on the sensitivity of the calibration. If it's more sensitive, meaning that you absolutely have to make sure you know this person is who they are, they're going to look at more points, and then when that biometric information is compared to the database, it has to be 100% match or very close. Now, hand geometry is not used as much. Hand geometry means that the reader is looking at the size of your hand, how long your fingers are, how long your thumbs are, and it actually will take these individual points in these measurements and then put them again into a binary format. So when you're going to authenticate, you'll just put your hand in the reader, and it's going to make the same measurements. But hand geometry isn't used as much as like a fingerprint scan or iris scan. Now, facial recognition is very interesting. This is something where the industry is continually trying to improve this technology because computers are not good at dealing with the grays in life. Computers are good at calculation, dealing with facts, binary, off, on. You know, it's all about the facts with them. What humans are able to do, we can guess at things. We can like to recognize a friend, if we just saw like a portion of the face, maybe they're turning away from us, we can recognize them. But a computer, it's harder because they have to have all the information to be able to recognize somebody's face. So there's issues if somebody is wearing glasses, or they get older, or they grow a mustache. It's harder for the computer to actually identify them. But the reason that the industry is putting a lot into this type of technology is because this is what they want to use to be able to find not only criminals, but terrorists and those types of people, suspects. And they already have cameras at football stadiums and the airport and different places where a lot of people would be to try to do facial recognition. It's continually advancing, but it's difficult for the computer to do this unless it's using more of artificial intelligence. And we'll talk about artificial intelligence and that type of programming in another domain. So this is just a comparison that facial recognition is one of the harder things for a biometric system to make a one-to-one match. Iris is the more accurate. And let me just say this, is that some people have a real hard time with the word accurate and biometrics, because anybody who's worked with biometrics, they know that there could be errors that we'll talk about. But when the CISSP exam talks about biometrics being accurate, it means that's the type of authentication that is that's the hardest to fake. You know, passwords and smart cards, those are easier for for the bad guy to fake it, but it's biometrics that provides much more protection because it's harder to be an imposter. So once again, the verification, once the client, the user sends the information over to the access server, and it'll just be like a regular, it could be a domain controller or just like any type of access server that you commonly have. You don't have to have a specialized piece of equipment. It's just that it has to have software to understand how to process this type of authentication information. So again, it's encrypted or it could be hashed. It's compared to what's in the backend database, and there'll be a yes, no. Either there's a failure, access denied, or access is granted. And of course there's issues with biometrics, just like everything else. There's always issues we have to look at. Because with biometrics, if let's say it's a voice print, which means that when I first am going to enroll with a voice print, it's going to give me words that I have to say. And then when I'm going to authenticate, it's actually going to move those words around so somebody can't just record when I say those words and replay it. So that it'll move those words around. But what if I have a cold, or what if I have a sinus infection or something? That can change my voice, and it may not authenticate me. Or if your finger, you have a cut or something. So these are issues that, like with passwords, we don't have to worry as much about with biometrics because it deals with the body or deals with how somebody carries something out. There's a little bit more sensitivity. Now, I said that there's different types of errors that could take place when we're using biometrics, and they're referred to as type 1 and type 2 errors. So a type 1 error would mean that I have an account, I've gone through the enrollment phase, and I try to authenticate, and I'm rejected. So type 1 is somebody should be authenticated, but they're rejected. A type 2 is when an imposter is actually authenticated. So if somebody doesn't have an account, they haven't gone through the enrollment, and they should not be authenticated. If that happens, that's a type 2 error. So I mentioned that there's a calibration with these devices, and it depends upon the sensitivity level of your environment. If you're using a biometric just at a regular workplace, you're actually going to allow some type 2 errors, because if you don't allow any type 2 errors, that means that that it's very strict, that you absolutely have to have a match between the biometric data and the data in the database. So if you don't allow any type 2 errors, that means there's going to be a lot of type 1 errors, which means that your users aren't going to be able to authenticate each and every time. So just like with everything with security, it's a functionality versus security balance. So in some environments, let's say somewhere in the government that has top secret information, they may have it where there's no type 2 errors, and in that they're just going to deal with it, that there could be more type 1 errors and their user may have to authenticate several times. So you calibrate it to your environment depending upon the level of protection that you need. Now there's a metric that's used within the biometric industry, and it's called the crossover error rate. And the definition is that when the type 1 and the type 2 errors are exact, when they're the same value. And how does this come into play? It's when like there's different vendors that make different types of biometric products, and you can go by their marketing data and they say, yeah, ours is very accurate and ours is great, ours is the best. But how do you as a user know that this is a very accurate biometric system? You don't. And that's why they're actually put through tests. The biometric systems are put through tests to figure out how accurate they are. And so the metric is when type 1 and type 2 errors actually are the same number that equals a CER value. So let's say one biometric product gets a CER value of 3. Another biometric product gets a CER value of 4. The lower the number of the CER value, the more accurate that biometric system is. So unless you're in the biometric industry or you've purchased one, a lot of people aren't familiar with this metric, but it's used. It's not just a CISSP thing. It's a CER value is when type 1 equals type 2, and it's used by customers to determine the accuracy of the device. So we talked about a few of the biometric types that are used in the industry. There's fingerprint and finger scan. Now, what's the difference between a fingerprint and a finger scan? Well, a fingerprint device will actually gather much more data on your finger. A finger scan will gather a fewer amount of points. Finger scans are used when you need to save on resources, because the more data that you pull out and have to save in a file takes more resources, and then when you have to do the authentication piece, if there's more data that has to match, that takes more resources. So a finger scan is basically the same thing as a fingerprint. It just takes less information from the finger and stores it for the authentication. There's a palm scan that looks at the whole palm. There's hand geometry, which I talked about, which is looking at the length and the width of the hand and the fingers. Retina scan is something that's used in some environments. Retina is the pattern in the back of the eyeball. So you actually have to get your eyeball really close up to a machine, which nobody ever really likes. And it's going to look at the pattern, because everybody's patterns with the retinas are unique, and it'll authenticate you that way. There's signature dynamics, which does not mean like when you go into the grocery store and you know how you sign on that little black thing after you run your credit card and you sign your name. That's not signature dynamics. That's a digitized signature. That's just capturing your signature, so we don't have to mess with any paper. Signature dynamics actually will collect electrical information as you write your signature. It's how you hold the pen, the pressure that you use, how fast you write your name, and then your signature. So all of those will be captured and put into a binary format. So because it's much easier to forge somebody's signature than it is to forge how they write their signature. There's keyboard dynamics. That's not used as much. It's you have to type some type of a phrase, and how long does it take you to type it, and the patterns that you would use. Voice print I talked about, where it'll give you words when you do your enrollment. It'll have you say these words, and then when you have to authenticate, it moves the words around. Now, passwords we all know about. They've been around forever. They'll probably be around a lot longer than most people want, because they're embedded everywhere. Passwords are the least secure type of authentication technology that we have, but it's cheap. They're the cheapest type of authentication. It's already embedded into an amazing amount of software, so our culture is just used to it. But they're weak because people choose easy passwords, they share the passwords, they write them down, somebody can figure them out, they're easily cracked. So one way you can try to enforce that your users use more complex passwords is to have a password generator. And this is actually a piece of software that will generate a complex password. You set how many letters and if you want upper and lower and symbols and all that, and it's going to generate a complex password. But the downfall is that people who have complex passwords, what are they going to do? They're going to write them down, because they're not going to remember. So a lot of users will write down their passwords, and where are they going to keep them? They're going to hide them under the keyboard, because nobody ever looks there, or they actually stick it on the monitor so that they can see it. when they need it. So that's a common thing. If it's too complex, users are going to write them down because they can't remember them. Now, most of us know what should go into making a secure password. And the best practices are that it's at least 8 characters, you're using upper and lower letters, they're not words, and we're going to talk about why they shouldn't actually be words. They're not shared, they have a proper lifetime, so you don't use the same password for 2 years. You know, the history, how long a password is good should be based on the sensitivity of the data that it's protected. So you may refresh your password every 90 days, maybe every 60 days. In some environments that require high security, top secret stuff, you know, they'll change their password maybe each day or every 5 days. We need to have the password history, which means that somebody can't use the same password over and over again when they have to change it. And a lot of times the software, that's the authentication software, you can configure it, and the common history number is 10. So the user can't use the same passwords for the 10 passwords that they have to use. So when they change it, it has to be a new password. And also there's acceptable failed logins. We need to configure that if somebody logs in or tries to authenticate, they put in the wrong password, that they can't keep doing it over and over again until they get in. That would be a brute force, where somebody tries over and over and over again until it's successful. So in the software, we usually have configuration that you can, after a certain number of failed logins, the account is suspended for maybe 20 minutes, maybe 2 hours, or maybe the account's suspended indefinitely, which requires the administrator to actually unlock it. And then, of course, all of this should be audited. The unique user account, time, date, what applications are being accessed. So these, you know, a lot of people have heard what they're supposed to do with passwords, and it seems as though, since we all know it, passwords would be very strong. But the reason that we have to keep saying the same things over and over again is because people use passwords like the name of their dog or their, you know, the favorite football team. When I've done assessments for the government, and after hours, it depends on the type of assessment we do, but after hours you can go into somebody's office and just kind of look around, and if figure out what they like. If there's a certain football team they really like, then that's what you're actually going to try to break their password. Or if somebody has a bunch of horses, you know, pictures of horses. So it's usually somebody picks something that's interesting in their life. So, you know, passwords is just the help desk and the administrator and people who are in the network will tell you that it's a constant support issue. And that's why when we get into identity management, we're going to look at the actual technologies that has been developed so that people will reset their passwords, or there's some way to not always have to call the support help desk when somebody forgets their password. So there's different types of attacks that are common to crack passwords, because that's what the bad guys going to want to do. They want to crack your password so they can authenticate as you and have access to the resource. So there's a dictionary attack, which we're going to walk through how that takes place, and there's a brute force attack. Now, brute force is also called an exhaustive attack, and it just means that you do something over and over again. In a password, how a brute force attack takes place is it doesn't just try to guess the whole password, it's guessing the sequence or the combination of the letters that make up the password. So in a simplistic way to explain it, it would be for the first character, is it an A, is it a B, is it a C, is it a D, until it gets it. Then it goes to the next character and goes through the whole thing, all the character, you know, the alphabet and numbers. So brute force is trying the sequence, where dictionary is trying to figure out the actual whole password. So how does a dictionary attack work? Well, there's several different tools out there to carry out dictionary attacks, which is the tool itself has a word list. And these word lists have a whole bunch of words on there. And a lot of times the tools come with word lists, and then you can download them from the internet. They have word lists in all different the languages. So you have, let's say that I want your password. Now, when you type in your username and password, your password goes over the wire. It shouldn't be in clear text. The passwords are usually hashed with like an M5, M4 type of algorithm. So when I get a hold, I sniff the wire, I get a hold of your password, I don't know what your password is yet. That's why I have to crack it. So I get that hashed value, and then the tool takes that word list and it starts at the top of the list, and it hashes that word, and it compares it to the password. So it'll hash each word in the word list and compare it to the password that I've collected until there's a match. So that's how a dictionary attack works. So once I have your encrypted password, I just pass it in this tool, and it does all the work. And it's amazingly easy to carry out. And a lot of times on assessments, if you're a security professional and you're doing assessments, this is the first thing you'll start to do. Like, let's say you have a week-long assessment. The first thing you'll do is you want to get that password list. You want to get as many passwords as you can and port it into a tool like LoftCrack, and it will work. It will start working on trying to crack the passwords. And it depends upon how well the company does, how strong they make their passwords, on how long it will take. So, but most passwords can be cracked, and then the attacker has your password. So of course, once they have your password, they can access whatever resources you can access. They work under a security context or the privilege that you have. So they can get in and get your personal information, maybe for identity theft. They can use your system to hack others. They can try to jump from your system to like a domain controller. So these attacks are not new, and there's a lot of tools that can be used to do this. There's Unix tools, there's Windows tools, and a lot of the tools are set up where you can configure it between a dictionary and an exhaustive attack. Because if it's just a dictionary attack, then it has to actually match a word in that word list. But if you do a combination of a dictionary and a brute force attack, then you can have, like, it means like the word would be password, and then let's say you use password for your password, and then you have the exhaustive or the brute force. It'll say, is it password 01, password 02, password 03. So that's how they work together, and it actually reduces the time it takes to break the password. Now, something that's a little bit more new in the industry is called rainbow tables. Breaking passwords, those tools have been around forever. What rainbow tables is that somebody figured out if they just took like all the words, all the combinations of letters and numbers, and go ahead and hash them, then you have not a word list of just words. You have a whole list of the hash values. So it's much easier to actually crack a password. And so what happens is I grab your password and it compares it to this list. Now this tool doesn't have to go through and guess what your password is. It'll just compare to the hash value. So I have your password that's been hashed like with MD4, and then it's going to compare to the whole list of all these other hashed passwords until it finds a match. And that's really reduced the amount of time that passwords can be broken. And that's one reason that the industry is trying to move away from passwords, but also corporate environments and government are increasing the size of their passwords because these type of tools and techniques are always coming out. So again, the things that we should not do, you shouldn't use a username as your password, which of course it sounds like duh, but I bet you're in a place where users actually do it. So if my name or if my ID is S. Harris, my password shouldn't be an S. Harris. You shouldn't use anything that other people can get a hold of for your password, like your address, your birth date, or a license plate number. It needs to be unique and hard to guess. So what do we have left if we can't use full words? Well, an easy way to come up with a complex password is to develop a phrase, something that you're going to remember. For example, take me out to the ball game. And what you do is you take the first letter of each one of those words and you use them, but you supplement some symbols for them. So like instead of an O, you'd use a 0. Another one is there's more than one way to skin a cat. And so you take the first letter of each one of those words and you don't use all letters, but for like a T, you put in a plus sign. For an A, you use the @ symbol. So these are ways to actually come up with complex passwords that you can remember. Now, some environments, the security team or the network team actually uses these type of products to figure out if their users are using strong enough passwords. Because you're really not going to know. I mean, you could set the software to say that the password has to be 8 characters, it has to have this upper and lower and symbols, but you don't necessarily know the level of complexity those people they're coming up with for the passwords. So some environments use like LoftCrack or one of those to test the strength of their passwords, but it's really important that you get management to sign off on that. There's been several instances where people have done that in a security team. They thought they were doing the right thing. They thought they were, figuring out if strong passwords were being used, but that's not how management saw it. They saw it as they were being too intrusive and figuring out people's passwords, which was none of their business. So you need to make sure that everybody understands and you actually have written permission to be able to test passwords this way. Now, another type of password is called a cognitive password, and it's not based on a specific string of values. A cognitive password is based on like your life experience. So when you enroll, and you have an account and you enroll, there'll be a series of questions that are asked of you. What's your where'd you graduate from school? What's your favorite color? All these questions that only you would know, and you're not going to probably forget. So when you go through the enrollment, you have all of these answers to the questions, and then when you need to authenticate, it's going to pick like 3 of those questions out of the whole set, and if you answer them correctly, then you can authenticate. Now, another type of password is called a one-time password, and just like its name says, you can only use it one time. And what's the benefit of that? What's the benefit of using a one-time password over a static password that you use over and over? Well, when you use the same password over and over again, that gives the attacker a bigger window of time to be able to get that password and crack it. Now, one-time passwords means that it's used one time, and even if somebody cracks it, it's not good anymore. So one-time passwords provide more security than using a regular password because it's only good for this one session. So if the attacker actually cracks it and then they try to use it to authenticate, the authentication service knows that it's already been used and won't allow them to authenticate. So it provides protection from replay attacks, which is just what I said, is that somebody cracks a password and they try to authenticate as you. That it can't happen with one-time passwords, or it's a lot harder to. It protects against eavesdropping, in that if somebody eavesdropped on your password, it doesn't matter because they have such a small window to figure out what your password is, and then they have to get it to the authentication service before your system does. Now, one-time passwords can be created in software or through an actual physical token. So what we use commonly today are actual physical tokens called synchronous tokens. And the one-time password is based on the time, and we're going to go through the steps of how this is calculated. But one thing I want to mention right here is that a synchronous token can be based on a time or event. Now, time means the actual time. It's using its own clock, and it's using that as part of the one-time password, or the synchronous device could be based on an event. And what that event would be is that you actually have this token, it has a little button, and you push the button, that's the event, and it will give you some type of value to use as your one-time password. Most of the synchronous tokens we use today are time-based, but for exam purposes, you need to know that there's two types. So if you have or you're using one-time passwords with token devices, you have to have the right software, of course. The users are going to have the tokens, and then on your authentication service, that the actual accounts are going to be created. And how it usually works, it depends upon the product, but usually like an administrator will set up your account, and then it's going to use like the serial number of your token device within the software that's going to be able to know what to do with these one-time passwords. So what happens is that, let's say I have a token. Now there's a number that's going to be shown to me that's constantly changing because it's the time. It's based on its internal clock. Now when I need to actually authenticate, I'm going to look at that number. I'll put in my username, I'll look at that number, and that number is my password. It's my one-time password. In reality, it's taking the time, it's using a unique seed, which is just a unique value, and it's giving me this number. So my username and this one-time password goes over to the authentication service. The authentication service will look up in its user account, yep, there's Sean Harris, and then it's going to decrypt what my one-time password is, and it's going to look at the value. And if the value is what it expected, then I'm going to be authenticated. Now, the value can only be what it expects if the clocks on the actual token and the clock on the authentication service are synchronized. And sometimes there's actually a shift where the token device will shift in its time, and it has to be like recalibrated. So again, if I'm using this type of system for authentication, I have some type of a username, some type of identification. There's a value that's shown to me on the token, and what that value is the internal time and a seed value that's combined. Then that is usually encrypted. It's sent over to the authentication server. The authentication server decrypts and looks at my account and sees if that's the one-time password that it's expecting. So those are the different steps. If there's actually, if they match, then I'm authenticated. If there's not a match, then I'm rejected. And these are being used more and more because access control the needs are only increasing because the attacks and people getting a hold of sensitive information. And like I said, in the banking, for online banking, the government has said that we need to have strong authentication for people who are doing online banking. So things like token devices are being used more and more. So there's, of course, software on the authentication server that the administrator is going to configure and set up about how the authentication is going to take place. We're going to look at another type of token called asynchronous token, because what we just looked at is synchronous token. It's called synchronous because it's synced up. The token and the authentication server is synced up. Now it could be synced up on time, which is what I just went through, or it could be synced up on event. And like I said, if it's event, then let's say I have a token, it has a button. What happens is I push that button and a new number is shown to me. then that value is my one-time password. I put in my identification number, I put in this one-time password value, it goes over to the authentication server, and the authentication server and the device, the token, they have the same list of numbers. So when I authenticate the first time, I'm going to send over the first value. The authentication server is going to be looking for that first value. When I push the button, that's the event, it goes to the second value. So my username and that second value is my one-time password. It goes over to the authentication server, which knows to go down to the second value. So that's what it means by event. Now, because we can't seem to call an apple, a lot of times we have more than one name for one thing. Event can also be called counter. It could be a counter token device, and you could see that on the exam. You could see synchronize, you could see event, or you could see counter. So event and counter are actually the same things, they're just two different labels. Now that's synchronous, and I'm going to explain how the asynchronous token works, but let's take a minute and understand how challenge response authentication happens, because I find that not everybody knows how that takes place. So let's say I need to, and I'm stepping outside of a token device right now. I'm just talking about regular challenge response that's in a lot of different protocols that we use today. So I need to authenticate, let's say, to my ISP to get on the internet. And it uses an authentication protocol like CHAP, Challenge Handshake. So it's going to challenge me. So I need to authenticate to the ISP. What I'm going to do is I'm going to send over my username. My system is going to send over my username, and then at the ISP, the authentication server, is going to look up in its database and see if it has a Sean Harris. If it does, it knows what my password is. It takes this password and it uses it as a key for encryption. It takes a value, some random value, which is called a challenge. It encrypts it with my password and it sends it back to my system. Now, if I've typed in my correct password, it will decrypt that challenge, and then I'm authenticated. Now, let me say it one more time. When you put in your username and password, you don't realize what's actually going on at the protocol level. So you put in your username and password, and what's happening is your username goes over to the authentication database. The authentication database looks for your name and an account. It finds Sean Harris. It looks at my password, which is just a value. It's just, it's in binary. So it takes a random number, which is called a challenge. It takes my password and it uses it as a key to encrypt the challenge. Then the challenge comes back to my system, and I have put in my password. If I've put in the correct password, my system takes my password and decrypts that challenge and sends it back to the authentication server. So this is what challenge response authentication means. And the benefit is that you're not sending your password over the line. You're just sending your username. Your password is used as a key to encrypt a value that's coming back to you. Now, we went through what a synchronous token device does. And remember, the whole name of the game here is creating a one-time password. And the one-time password provides more protection because it can only be used one time. Now, there's another type of token device that provides a one-time password called asynchronous. What we went through was synchronous because the token device and the authentication service is synchronized based on time or event. And now we're going to look at how asynchronous token devices work. So this is a little bit more complicated. If I have a token device that works as asynchronous, what's going to happen is I'm going to actually send a request to the authentication service and say, hey, I want to log in. What it's going to do is send me back a random value. Now I take that random value and I punch it into my token, because asynchronous tokens actually have a little keypad. So I take the random value that came from the authentication server, I type in that random value. Now my token takes that value and it encrypts it. It could hash it or encrypt it, but it will take that value and change it. Let's say it encrypts it. So then it shows me a new value. Now that new value is my one-time password. And then I put in my username, I put in that new one-time password, I send it over to the authentication server. It will decrypt it because it has the necessary key. If it can decrypt it and it's the value it's sent over, then I'm authenticated. Let me say it one more time because I know people have a hard time with this. I want to log on somewhere. So when my system is actually going to send a response to the authentication server is going to send a random value back. I will see that random value on a screen. I'm going to put it into my token. I will type it into my token. My token device will encrypt that value so I see a whole new value. And then I put in my username, I type in this new value, it gets sent over to the authentication server. The authentication server will look up Sean Harris' account, will have the necessary key to decrypt that. If it can decrypt it, it knows that it came from this token. That's how it knows of what you have, that you have the right token. Because if my token device encrypts it, that has a key within it that matches the key on the authentication server. So the authentication server, if it could decrypt that information and it's the value that it sent over in the first place, then I'm authenticated. So this is asynchronous. Asynchronous means there's steps involved. Versus synchronous means that the authentication server and the token device are synchronized. Now, in the industry today, asynchronous is not used as much as synchronous because there's too many steps for the user. Usually we use synchronous, and usually it's time-based. So here we just go through the initiation, which means you send over a request to authenticate. There's a value that comes back. The token encrypts that value, sends it over to the authentication server, and comes back with, you use that value as a one-time password, just like I just went through. Now, I said that we were going through the different technologies that are used for authentication. We talked about biometrics, we talked about passwords, we talked about token devices that create one-time passwords. Another common way that we do authentication today is use some type of crypto key. Now, I'm not going to go into what type of key is used when right now because we have a whole domain on cryptography. But what you need to know is that using cryptographic keys is one way to authenticate, and then in cryptography we'll go through all the different types of keys and how they're used. So another common way of authentication is using a passphrase. And a passphrase really is just a longer password. And it's usually a phrase like stick with me kid and you'll wear diamonds, that whole long phrase. And since it's a phrase, the idea is that you'll remember it versus a password that's actually that many letters that are random. Now, when you use a passphrase, it's actually going to take those letters, those characters, and turn it into what's called a virtual password. And that's something you could see on the exam, that a passphrase turns into a virtual password. But a lot of people doesn't really know what that means. Well, in the application only has so many bits that are allocated for your authentication, for your passphrase. So you can have, you could type out Moby Dick, but you can't actually, the whole book, you could type that all out, but the application can't deal with all of those letters. So it's going to take whatever you type in, your passphrase, and put it through like a hashing algorithm, and then it's going to be the size that the application has already committed to. That's what a virtual password is. So passphrases are commonly used to protect keys, and when we get into cryptography we'll talk about PGP. PGP is a email client that commonly uses passphrases to protect private keys. And there's other applications to use passphrase, but it usually has to do with protecting some type of a key. Now, we're continuing with the types of authentication technologies that are used today in the industry. Now, you can use a memory card, and what a memory card is just, you know, like your, maybe you have a proximity card that gets you into a building, maybe you have a credit card. It just means that it has that magnetic strip on the back, and that magnetic strip actually holds data. You put it into a reader, you type in a PIN number, and it depends upon how this memory card is actually made. Sometimes when you put in your PIN number, the PIN number is encrypted and stored on that magnetic strip. So the reader is going to take what you put in, encrypt it, compare it to what's on the strip. And then if you type in the right PIN, you're authenticated. Some of the cards, when you type in the PIN, it actually is going to go over to a back-end database, and that's where the PINs are stored. That's deeper than what you need to know, like for CISSP. For memory cards, you just need to know that this is a way to authenticate. Memory cards, they can't do anything. They can't process data. They could just hold data. And you can get data from a memory card. You just need to get a reader. So on a memory card, there's no microprocessors. It's no integrated chips. It can't do anything. It just holds data. And so our ATM cards, credit cards, and those are commonly memory cards, and we commonly use them for authentication to get into maybe sensitive areas or into a building. Now, smart cards is a lot different. They could look very similar, but a smart card actually is a little computer. It has a microprocessor, it has integrated chips, and it actually does stuff. It doesn't just hold data, it actually processes data. So what happens is you have your smart card, and when you put your PIN number in, it unlocks the software on that smart card. That's what your PIN is doing, is unlocking the functionality or the capability of that smart card. And you know it's a smart card because it has that little gold rectangle on it. And what that rectangle is that's how it communicates with the reader. The smart card doesn't have its own power source. It has to get it through the reader. And that gold rectangle is the import-output component. That's how the reader and the card communicates to each other. And then there's something called microprobing, which means that you're going to take the card, you're going to peel back that gold piece that is the import, the I/O port, and then you actually have like a laser to strip back the film or what's actually protecting the integrated circuits, and then you just connect directly into that circuit. So you are taking this card, you're getting directly into the circuits. You actually, because all the circuits have like a coating to protect themselves from heat and the environment, you strip that back and then you clip right into the circuit itself, so you can get the information directly. Now, smart cards could do a lot. Since they're actually a small computer, there's a lot of things it could do. It could create a one-time password. So maybe you put in your user ID, you put in your smart card, and it creates a one-time password to authenticate you. It could hold biometric information. So like I said, that the military, everybody has an ID now that's a smart card. On the smart card they have a biometric template that holds the soldiers and the airmen. They have their fingerprints that are held into that smart card. So when they need to authenticate, the biometric data is taken from the smart card and it goes to a back-end server to authenticate them. So the smart card could have your private key interact with a PKI. It could do a lot of things. It could hold information, and really outside the United States, especially in Europe, smart cards have been used a lot longer than inside the United States. The United States is kind of slow to pick that up. So there's two types of smart cards, contact and contactless. And it's really like what it sounds. A contact smart card means it actually has to make connection with the reader, and that's how the communication takes place. A contactless smart card actually has an antenna within the card itself, and the reader can sense when, like, you're walking towards a reader, it will sense that there's something out there, and it'll send out interrogating signals. And these signals will communicate with your contactless card, read the data that's on there, and then authenticate you or allow you to get into a locked door. Now, there's a lot of different types of attacks that could take place with smart cards. And why would somebody want to attack a smart card? Well, it usually holds some type of sensitive information. Maybe it holds your private key, maybe it holds your medical information, your social security number, something. So since it's being used to for authentication, there's going to be people that are motivated to compromise it in some way, so they could either get the sensitive data that's on the card, or they could use that card to authenticate as you. So we're going to look at some of the more common attacks that can take place with smart cards. Now, there's a fault generation attack, and what that means is that you're going to change something within the environment. Maybe the reader, you're going to change the voltage that it uses, you change the clock speed that the reader's using. The goal is to change something outside the card to make it break down, make it give up information that it's not supposed to. So you're manipulating something that the software on the card can interpret and will, it's just like breaking into software. It's going to give you some type of information that it's not supposed to. So fault generation just means you're manipulating something outside the card to get into the data that's on it. And then there's software attacks, because since the smart card is a computer, that means it has to have software. And so just like attacking a web server or an application, this software on the smart card can have flaws, and most software does. So you can put bogus information, or maybe even buffer overflows, or some type of data from the reader that will go in through the I/O port of the card, and will make the card be wide open for you to actually gain the data that's on it, or maybe it will give you control that now you can change the PIN and you can use the card yourself. So a software attack is just like any type of attack on any type of software, and hackers are just going to try over and over again until they find the actual flaw to exploit, just like in an application. Now, a side channel attack is much more sophisticated, and they're not used just with smart cards. Side channel attacks have been used for other purposes, and we'll actually look at this type of attack again in cryptography. But a side channel attack means that you're not actually doing anything to the smart card. You're not changing the temperature around it. You're not changing the voltage from the reader. You're not sending data into it. A side channel attack means you're just watching. You're just gathering information on how it works. And you gather the radiation that comes off while the smart card's doing its thing, the time that it takes for the smart card to activate. So these are very sophisticated types of attacks that have been successful to be able to figure out how to break the smart card. And again, it's been used in cryptography to figure out, like a private key. You just watch and gather information to see how that thing works instead of being intrusive and trying to actually attack it. So these, of course, this isn't something that happens necessarily commonly, side channel attacks, because because of the level of sophistication. But if you think about it, the more and more that we use smart cards, the more that we depend upon them, the more that there's going to be attacks. If there's no sensitive information on my smart card, you know, who's going to really care? But like over in Europe, they use these smart cards as money. They have money on the smart card, and they put it into a reader, and it deducts from how much money is held on that card. So there's going to be more and more sophisticated attacks as these cards are used more and have sensitive data on them. Now we're going to go into a section that covers identity management. And this is actually quite a large thing in the industry that takes a lot of different types of technology and processes and people that need to do different things. Identity management is really a complex thing because so much is involved. So if any of you have participated in identity management rollout, you know how complex it is. And we're going to look through not all, but some of the technologies that are required for a full enterprise identity management solution. And we're going to, of course, cover what the CISSP exam will cover. But really, there's actually other technologies that are usually involved also. So identity management itself it's a term that, you know, different people have definitions too. And the reason is because there's so much involved. There's so many different products. There's so much that has to be involved, like I said, for enterprise identity management. And so you can ask 5 different people about really what identity management is, and you can get 5 different diverse answers. It's like the thing with the 4 blind guys that are trying to figure out what an elephant is. One touches the trunk and says, this is a trunk. One touches a tail and says, this is a tail. So with identity management, most people will associate whatever they're familiar with, because it usually has so many different types of technologies involved. They will say it's provisioning, or somebody else would say it's access control, when really it's a mesh of all of this. So the term is if you're ever talking to somebody using this term, make sure that you're on the same page and you know exactly what they mean by identity management and what you mean by identity management, because I've seen a lot of confusion in the industry so far. So in an environment, our environments are so complex. We have all of these different servers, different applications, we have legacy systems, we have mainframes, we have different types of employees, wireless networks. If you really think about all of the types of applications, platforms, mainframes, wireless, roaming users, customers, partners, we have to control access with all of that involved. And that's why identity management is such a huge undertaking. And so our environment is continually changing. Our environment is dynamic, so we have to have automated processes to continually enforce our access control and our user management control in a standardized method. So what are common concerns with not having a whole identity management solution in place? Well, it's who should have access to what. You know, users, I've talked about before, usually have way too much access because it's just easier that way for the administrator. Just give them more access than they need. They're not going to come back and bother me and ask for anything else. So to actually practice least privilege, what users need what access? How do we know that when an employee is laid off or fired that all of their accounts have been disabled? Not just one, like on the domain controller, but all of the accounts. How do we revoke access? How do we change permissions when somebody moves from one position to the other? Why do our users have to have 6 to 8 passwords to remember to get onto the different resources within the network? these are all the pain points that almost every company is running into, especially the larger companies. And that's why identity management is becoming more important, and because we have to protect the sensitive data. So as it becomes more important in the industry, it'll be reflected on the CISSP exam. So again, we have so many different types of users in most environments. You could have consultants, contractors, partners, employees, temp employees, and they all shouldn't have the exact same access level, especially contractors and consultants. We need to keep a tight control on taking their access away when they're off the job then. And then we have different data at different classifications. How do we know who can access what classification? A lot of times companies have tried to do this manually, where you configure systems on who can access what through ACLs, and that's just, it's overwhelming. It can't be done manually in environments that have so many applications and so many different platforms. Another thing that not a lot of people really understand is that there's a lot that goes into a digital identity. Your identity is not just your username. There's a lot of things that actually go into your identity. Your credentials, maybe some personal data on if you're a manager or what department you work in, if you have a digital certificate, if you use cognitive passwords, contact information. So all of this data is brought together, and that's what digital identity is all about. It's and that's the new term, that digital identity, because we are going from one place to the other, one website to the other, but within an organization, in no way is a user's identity just their username and whatever, password. It's usually more complex than that. And like I said, the corporate environment is constantly changing, so even if we had it all set up right 1 week, the very next week there's going to be other changes that are required with access control and user management. So a lot of environments, and again, like I said, the larger environments, it's chaotic. There's so much interaction that has to happen between the different types of users, the applications, the services. Most companies really don't have a handle on how all access is taking place. It's very easy maybe in a domain with a domain controller, but not everything can be controlled by a domain, legacy systems and different types of applications. So identity management is technology and processes to really get this chaos under control, so that we can make sure that users only have the access they're supposed to, and that we're protecting the assets that we're supposed to. A lot of environments, and again, like I said, the larger environments, it's chaotic. There's so much interaction that has to happen between the different types of users, the applications, the services. Most companies really don't have a handle on how all access is taking place. It's very easy maybe in a domain with a domain controller, but not everything can be controlled by a domain, legacy systems and different types of applications. So identity management is technology and processes to really get this chaos under control, so that we can make sure that users only have the access they're supposed to, and that we're protecting the assets that we're supposed to. So what's interesting is like I said, is that the digital identity is more complex than most people know. There's what's called me, and that means there is information on me that I know about, and I can usually update if I need to. My address or my phone number or my email address, that would be referred to as me data. Then there's known me. What that means is I know that there's certain type of data that's kept about me, but I can't change it, like my access level or how much money I have in a bank account. I know that there's that information kept on me, or my credit rating, but I can't change it. And then there's what's called unknown me, which is data that's kept on an entity that I don't know about necessarily. You know, a digital certificate may hold some type of information. There's other types of data that's collected on all of us that we don't know is collected. So in an environment with identity management, that you're going to have to figure out how you're going to make your access decisions, because it's not usually just on a credential. It could be a credential if this person is a manager, if this person works 8 to 5 Monday through Friday, that's when they can access a certain type of data, if they have secret clearance. So there's all these things that actually have to go together to form the digital identity so that access control and user management can be carried out properly. So the different technologies that are used in identity management, especially what's going to be on the CISSP exam, is directories, web access management, password management, legacy single sign-on, account management, profile update. That's a list of the technologies that you'll need to know that makes up an identity management solution for an enterprise, and that's what we're going to cover. Outside of CISSP, there's actually a few other things that can even make it a little bit more complex, but we're going to break it down and talk about each individual technology. One of the main components within an identity management solution is called a directory. Now, a directory isn't a database. A directory usually lives on a database, and most directories, databases that are used within identity management are based on the X.509 standard, the X.500 standard. So usually the directories that are used within identity management are based on a database that uses X.500 standard and being accessed through an LDAP protocol. So the directory is the most important because it's the one single place that almost all of the user identity information is collected. There's identity information that's all over the enterprise, and it has to be put in one place so that the different access control, user management, different identity management tools will have just one place to be able to get information to be able to carry out their functions. Most environments have some type of a directory already in place. Even if they don't have a full identity management a solution enterprise-wide, usually you have some type of directory. Maybe you're running Novell, or maybe you're running Microsoft Active Directory. But that's really different than a directory for identity management, because the directory for identity management would actually could pull information from Active Directory or the Novell directory and be centralized and have all this information, not just from a domain controller, but all information throughout the network. So what is the responsibility of the directory? Well, again, it has all this information collected, and it pulls the information, and it could be different things. It could be, it's always user identity information, and like I said, digital identity is not just based on a credential set. You could have identity information in a SQL database somewhere. You could have it in an HR system. You can have it in Active Directory. So the responsibility is that it gets this data, and when there's an update, it actually sends it out. So when there's a new user, it could send out this information and update all the other components that are holding some type of identity information. So it's a bi-directional flow where it's pulling data and then it'll push new data out, so everything, all the tools and all the software are up to date. Now, what the directory actually pulls from and does not go back and update is called an authoritative source. An authoritative source is where the identity the real identity actually came from, where it started. And in most identity management solutions, it's being pulled from the HR department, the HR database, because the HR database has, all the information on the employees and the contractors, has their contact information, their address, their role within the company, their manager's name. So the authoritative source is where the identity starts, and that is, the most correct information within the environment. So again, it's usually the HR database. So the directory, the identity management directory, will pull the data from the authoritative source and have all of this information in one place, so the different applications and tools that need to use it to be able to carry out provisioning, workflow, user management, access control, they will pull it from this one source. And so again, directories in identity management, they will do a bidirectional update to these other components, but of course they're not going to update the HR because the HR database is the authoritative source. HR data comes down, and the directory can't change it because HR has the most up-to-date information on that identity. In a lot of environments, there's a directory, and then there's something that's called a meta directory. And the meta directory is really the one that's actually doing what I'm talking about, really going out and pulling all of that information. Meta directory, metadata is data about data. And so you can have a directory that all the tools and all the applications communicate to, and then you have a meta directory that actually is collecting all of the identity information and feeding it into the directory. So if you think about, you have a directory that's centralized, that has all the information for access decisions to be made, and all of the applications that need to make identity management processes. The directory is a centralized place. It could have a meta directory that's actually going out and getting the information and then populating the directory itself. Now, it could be a meta directory, which means that it actually has the information that is pulled from the different what's called identity stores. So it would pull information from maybe a SQL database, maybe from a mainframe, maybe from some type of server, maybe from some type of another type of database. So the meta directory means the data is actually there. Now, what the industry is moving more towards is what's called a virtual directory. The virtual directory doesn't actually hold all of the data in one directory, in one database. It knows where all the information is. So when a request comes in, let's say a user wants to access a resource, there's going to be a request that comes in and will look at the data or ask for some specific data from the directory. Now the virtual directory knows where the information is on the other system, so it will redirect to where that is. So a virtual directory doesn't actually have the information physically there in a directory, in a database, but a meta directory does. So if we look at this slide, this is really how things kind of work in directories and within identity management. You have the virtual directory. In this slide we have a virtual directory, which means that it's responsible for getting all the identity information and possibly security policies from the different sources throughout the environment. It has all of that within the virtual directory, and that's available now to the resources that need that information. So we could have web services that's going to access the virtual directory through HTTP. We can have another directory application that's going to access through XML or web services. We have a database that needs to access the information in this virtual directory, maybe coming through LDAP. So you see on the top, those are the applications that need to communicate. They need to gather the data and use the data in the virtual directory. Now you see the bottom. The bottom is where the virtual directory has actually pulled its information. So we have like LDAP will communicate to different directories throughout the environment. We have ODBC, which means that it's communicating to a database. So at the bottom, those are what's called database or directory connectors. They connect to where all of the identity stores are that has information. It's pulled up into the virtual directory, so then it's available for all the different applications to come in and access and use it as needed. Now, something that's probably a little bit more familiar to us is web access management, and that just means that the administrator can control who is accessing web servers. And this is very common for e-commerce or any type of any type of web service. You have dynamic information being given out to users. Now, web management, web access management is usually a plug-in that goes into the web server, and usually it's going to be controlling a web server farm. So it will control the access. So when there's an actual request that comes in for access, the plug-in isn't going to make the decision. That's not where the credentials usually sit. There will be a access request that come in, and then it knows where to point to the database that has the credentials. So it'll point to send off this request and then to wherever the credentials are sitting, which could be Active Directory, it could be a KDC, it could be anything that's holding credentials. If there's a match, then it comes back, yes, this person can have access, and then now that person can interact with the website. Now with the web management tool, it's not only providing access control, it also will keep state on a user or provide a single sign-on capability for the user. And that means if, let's say that you log into your online banking account. First you go to the website for the bank. Now, you're just looking at public information, store hours, rates on CDs, and at that point, you don't have to authenticate because it's just public information. Now, when you actually hit go to my account, then the web server, the actual web management software, is configured so that it actually has to set up a secure connection with that user, with that browser, and now it's going to keep state on this connection, which means it allows for single sign-on capability. Single sign-on means that the user just has to present one set of credentials, and then they can access different resources. So in our example, let's say that you say, I want to go to my account. Then the web server is actually going to set up an SSL connection with your browser. Once that's set up, it's going to ask for your credentials. So you'll send over your credentials, maybe it's username and password. Then the web server is going to pass it off, your credentials, to a database to make sure that you sent that in and that you could have access. It'll come back, the web server will say, yep, you can have access, and then show, let's say, your checking account. Now, this communication is actually taking place over HTTP, which is a protocol that is stateless. And stateless means that web servers, when you go to a regular web server, you make a request for a page, the web server sends over the page and forgets all about you. It doesn't keep any information, it doesn't remember that you accessed it. And HTTP was developed specifically for that in a stateless, because web servers are hit all the time and they're usually just serving up web pages, so it would take too much resources for the web server to keep track of all the users who are asking for website pages. So HTTP is stateless. Now, when there needs to be a connection that is kept, which means if you have a single sign-on set up with the website, that has to keep state. That means that connection has to stay there. The server has to remember and keep track of what you're doing. So once you send over your credentials, what's going to happen is there's going to be a little cookie that's created, which is actually like a text file. The web server is going to send that cookie back to your browser, and it's going to it'll stay in memory in your browser. Now, let's say you're looking at checking. Now you want to go and look at your savings, and the web server is like, "Whoa, you can't. We have to make sure you have access to this." And the web server will make a request to that cookie to see if you are authenticated and to what level, and then it'll allow you to go into the look at your savings. The web server will actually continuously look or probe this cookie to make sure there's no man in the middle, to make sure that somebody else isn't actually hijack the session. So it's going to continually check the cookie to make sure that you are who you say you are, and you've already properly authenticated. And that's what it means to keep state. It's tracking exactly what that user is doing. So whatever you do, deposits, withdrawals, looking at different accounts, it's going to make audit trails of all of that, and it's going to remember and track all that you do. So that's what it means to keep state. And so again, the web management access is commonly a component in the whole identity management enterprise solution, because the outside users are usually coming in through the web server farms. And they we want them maybe to have a single sign-on so that they don't have to keep authenticating for the different resources they want. And then we'll have a different technology for the users that are internal to the network and not use the web management access component. Now, earlier we talked about passwords and how passwords should be complex and how we shouldn't share them and all the rules. And I also said that passwords are quite a pain to most help desk employees and the network employees, because people are always forgetting their password, and then they call and say, "What's my password?" So that usually takes a lot of man hours. And so within an identity management solution, a lot of times there's password management technologies. And the technology, there's 3 different types. There's password synchronization, and what that means is once your password is set, it goes to the technology that does password synchronization. It takes that password and it sends it out to all the resources that you have access to. So if my password is blah, then blah will be my password to this server. Blah will be my password to this application, etc. So it's not single sign-on. It just means I have one password that I'll have to remember to get into the different applications. Now there's also a self-service password reset. And what this means is that you can actually, the users can change their passwords, reset it themselves instead of having to call help desk. And how that works is, let's say I forget my password. Well, when my account was set up, there was already like cognitive questions asked of me. Where did you graduate from school? What's your favorite color? All of this information. So when I go to this self-service password reset, it will ask who I am, and then it's going to ask those questions, like 3 out of 10. If I answer those correctly, then I can go in and reset my password all by myself. But again, I have to authenticate to it by providing these cognitive information that was set up during the user account setup. So another piece of most identity management solutions is what's called a legacy single sign-on. And we're actually going to go into some single sign-on technologies in this domain. But right now, what we need to know is that single sign-on just means that I can log in with one credential set, and then I can access the necessary resources. Now, again, there's a difference between password synchronization and single sign-on. Password synchronization means that each different application and device has my one password. So if I need to go into a server, it's the exact same password as if I need to go into an application. Single sign-on means that I authenticate to the single sign-on technology, and then when I access a file server, when it comes back and it says what's the credentials, the single sign-on will provide the credentials. I don't have to. The single sign-on will do it for me. So the single sign-on is kind of, whatever authentication requests come that are supposed to come to me, it intercepts them and answers for them. So, do we have any issues, any security issues with single sign-on? Well, of course, that if I only have to remember one credential set, then there's only one credential set that the attacker needs to figure out to be able to access all the resources. So then that's called keys to the kingdom. So that's a vulnerability to single sign-on and password synchronization. They only have to have your one password or whatever your credential is to be able to access the resources. So, some people would say, well, why in the world would you do that then if it has that type of vulnerability? It's always that, business needs and functionality versus security, because a lot of environments, people will have, 4, 6, 8, 10 passwords to remember to get into the necessary resources, and they're going to write them down. Actually, writing them down provides less security. And with single sign-on and with password synchronization, the goal is that you can actually enforce a more complex and secure password policy, since the user only has to remember one. So hopefully they'll you can enforce them to use one password that's actually strong instead of having write down like 6 passwords. Now, another component of the identity management solution would be account management. And we talked a little bit about account management. Account management always has to take place, no matter if you call it identity management solution or not. But in identity management, the account management software, actually there should be a workflow set up for how accounts are going to be set up, how they're going to get approved, how permissions are going to be assigned to it. So in most environments, what happens is that, let's say there's a new employee. That data about the new employee comes down to the directory, and another thing that comes down to the directory is who the manager for that user is. So the new employee information comes down, maybe that they're a manager, what department they work in, the time that they work 8 to 5, and who their manager is. So then automatically through the user management software, there's a request to the manager and says, hey, this person needs an account, and can you approve it? The manager has to approve that account. Now, it could be the manager, or it could be somebody delegated with this type of approval. Then once that is approved, then the accounts are set up. Now, the accounts can be set up automatically at the different systems, or like a ticket could go to IT and said, set up these accounts for this user. So again, account management you should have a workflow process, and what that means is, how are we going to set up accounts? How are they going to be approved? How are we going to audit them? How are we going to log them? And this is a common way: HR to directory, automatic email to manager. Manager says yes. and approves this account, and then the accounts can be set up, or the accounts on the different system for this one user could be set up. Now, you may have heard of provisioning, and provisioning and account management, they go together. Provisioning means assigning the user specific resources or allowing them to access specific resources. And this all works together. All of these technologies have to work seamlessly to provide a whole identity management solution. So again, let's say a new user comes, a new employee comes in the HR database, it goes down to the directory sends out an email for the account, and the manager approves the account. Now, it's not just approving the account. You have to approve of what type of access, what type of privileges, all of this stuff. And although the CISSP exam doesn't really go this far, but I'll just tell you, in reality, that manager doesn't know what kind of access or permissions that this new user should have. They can't go through and say, he should have read to this and he should have right to that. What's really in identity management, what's really set up is roles. Roles are set up, and that the manager will assign this new user to a role. That role already has rights and permissions assigned to it, and what type of resources it can access. So I haven't seen that the exam is actually making that connection, but in reality, you actually don't start to set up an identity management solution until you have a role-based system already set up. So again, provisioning means that you're allowing access to the resources within the environment. And why a lot of this stuff is confusing is because there's not one application, there's not one product that's going to do all of this. You can have a meta directory product that does user management, let's say. Then you can have another product that does provisioning. You can have another product that does access control. It's a very complex beast, and it's very expensive. And since you have all of these different products that have to carry out identity management processes, there's a lot of customized programming that has to take place for everything to communicate, not only those tools to communicate to each other, but then to communicate to the resources that are on your network. And that's why, because of all of this customized programming that needs to take place, it takes place currently, that's expensive, and it's very time consuming. And then if you need to make some changes, it's customized, which means you have to get that program or a similar one in to make changes. So that's why the industry is moving towards using open standards like SOAP, XML, those types of things. Like the exam is not that far along yet. It's not going to be covering SOAP and XML and SAML. It's not covering those things yet. But I'm just telling you, in the reality, this is a complex thing. All of these pieces have to work together. Right now, we do a lot of customized programming, but the industry is moving to more of a web service based environment, so it doesn't have to be so time consuming. Now, access control isn't just about what applications or what data can be accessed. It's also, you should, within this provisioning service that's within your identity management, it should be physical access also. So a lot of times when you have a new employee, a manager has to approve that they can have like a proximity card that allows them into the building or allows them into the server room. So this is, this information is all logged and holds people accountable. This person is new, somebody has to approve that they get access, that approval is documented, and they're not just handed a card. And another technology that you need to be aware of is called Profile Update. It's a tool that allows users to update the information in their profile that they can have access to, but it doesn't allow them to make changes to things that they're not supposed to, like their privileges and such. So it's much easier to allow a user, let's say they move and they have a new address or a new phone number or something like that. Instead of having to go through and fill out a form and have somebody else update it, a profile update technology will allow the user to go log in, make those changes themselves, and to keep it fresh. But again, the profile, a user's profile, doesn't just have that type of information. It has other informations, maybe their digital certificate or not necessarily the digital certificate, maybe their access level on different applications, you know, like I said, maybe their credit rating or background check information that's been done, or their clearance level. So within the profile, the user can update the information that's accessible and safe for the user to update, and then the administrator can update the other components to keep it safe. We've covered a lot of different technologies. We're going to cover one more that falls within identity management, but let's just take a real quick review. If we look at this slide, you see that external users, they'll come in like through web apps. If they're coming in through web apps and they need to access web-based resources, then we have web management access control tools. Remember, that's the plugin on the web server that is allowing access from the external user, and it will allow, most of them are going to allow a single sign-on to take place for that user. So that's usually the external user. Then with the internal users, that's when you have your the profile update and the password synchronization and the things the other items that we've talked about. And I think that this is a good graphic where it breaks down between what access management is, what identity administration is, what identity provisioning is, and what directory services are, because all of this stuff gets real jumbled, and in reality, a lot of the products actually combine several of these functionalities, so it even gets more. But you see that we have identity, we have authentication, we have authorization, we have delegated administration, which means that you could delegate maybe administrator to do a piece. So you can have like a high administrator that can configure and control a lot of things, and he could delegate to other administrators where they can keep control of smaller things. We have registration, password, self-service, and the directory service. Remember I talked about the directory and why that's so important? Because that has all the information that these other tools and products are going to connect to. And remember, it's usually an LDAP directory, and it could be using a meta directory or a virtual directory. So, and you see at the bottom there that they connect to, the directory actually connects to the systems that it's pulling information from, so that it has all the information in one place, and it's actually updating those applications and databases too. And then there's a workflow part of it. The workflow is how all this stuff takes place, because it all has to take place in steps. And then everything has to be audited, things need to be monitored. So there's not one application that does all of this. And that's why it's so complex. Not only are our environments complex, keeping track of all of this properly is complex, but we're moving there because we have to. We have to know who's accessing our resources, that the people have the necessary level of access, and that we're doing what we're supposed to of protecting like sensitive data, social security numbers, health information. When I started this section, I said that identity management means different things to different people. And there's a good reason for that, because not every identity management solution is the same for every environment, because they don't need maybe all of the pieces, maybe they need some of the pieces. So don't think identity management is like one product or one single set of products. It is what the enterprise needs, but the overall goal is to control user access, do authentication, authorization, provisioning, meaning assigning resources or allowing access, single sign-on. So overall, that's what identity management is, but there's, again, a lot of pieces and parts, and that's why a lot of people are confused about what the term actually means. So there's, we could have single sign-on, we have collect information for personalization. Let's say our internal users are going through the web, our web server, and a lot of times there's information collected on their browsing habits, or when they set up what they're looking at. That's personalization information that will be kept in that cookie. So the next time that they come to our web server, we'll have the presentation as they set it up before. So how do you know if your company needs identity management? Most companies every company needs identity management. It's just, to what degree. Some companies can just deal with maybe having a Novell or Microsoft or a Sunbox that can control access to the resources. But those are small resources that, or that's a small environment that is not heterogeneous. It doesn't have a whole bunch of different types of applications and devices and operating systems. Most environments are heterogeneous, meaning they have a range of everything, different types of devices, different flavors of Unix, different versions of Windows, mainframe, legacy. So if you have an environment like that, that's one thing to key in, which most are. If your users have more than 6 passwords that they have to remember, they're writing them down. So you need something, some type of identity management to control that. If it takes your company more than a day to set up a new account, then you probably need something like this. If you're unable to revoke access from an account within a day, that's not good. You need something that's automated. So there's, some companies have pieces and parts of identity management. A lot of companies are building whole enterprise identity management solutions, and those are usually the larger companies. So again, what you need to know is like the password management, user management, web management, legacy single sign-on, those components that actually come together. That's what you're going to see on the exam. Now, I said that there is one last technology we're going to talk about that has to do with identity management, and that's called federated identity. Federated identity means that you authenticate at one system, and then that authentication allow you to access multiple systems. Now, that sounds like single sign-on, and in a way it is single sign-on, but federated identity usually means you have a lot of different companies that are using the one set of authentication information, not necessarily within your company. So let's say that you go to Southwest, their website, you book a flight, and then it says, do you want a hotel? Now, if I click yes, I want a hotel, I could be taken to Hilton website. Now, I don't have to log in to that website, because what's happening in the background is Southwest has taken my credentials, my authentication information, and passed it over to Hilton so they know who I am. this is only set up if these companies trust each other. They have to have a trust relationship set up to be able to share this type of information. So federated ID makes it easier for the user in that they authenticate one time, and then each place that they go, they don't have to log in, and also their security context is going with them. That means the level of authorization that they should have. That's how it is for the user. For companies, it's easier because you don't have to log in to each one of them, and the sell can happen much more quickly if they don't have to log in. So federated ID is something that's really kind of new and just starting to flourish in the environment. So again, as an example, it is between companies. So let's say that I want to have access to company B. Well, I authenticate through company A, and then company A passes my authentication to company B, and company B will allow me to access their resources. Now, again, I'm going to step outside of CISSP just for a minute, because you really need to know just the basics about federated ID. What's actually going on is we're using web services and SOAP and XML and all of that, open standards. That's what allows for this type of thing to take place, is open standards. But the exam hasn't gotten that deep yet. You need to know just basically what federated ID is and what it allows you to do. Now, we talked about identity management, and one of the big threats is identity theft, and that's why a lot of these new tools and this technology is going out into the industry. Identity theft is the fastest growing white-collar crime. When identity theft attacks take place, somebody is getting your personal information, credit card number, social security number. They want to, they may want to buy something in your name. You have good credit. They're going to buy something and put it on your credit card. They may sell it. They may actually sell your information so somebody else could use it. They can get IDs. There's maybe somebody isn't supposed to be in the country, and they can use your information to go and get maybe a driver's license or social security number. So identity theft is, a lot of people, even non-technical people, know of identity theft and have heard about it, but don't necessarily know all the ways that it takes place. Now, I had mentioned that there's a lot of tools to set up websites to be able to collect information very easily, and it's happened really over a few years. Amazon, it happened to them. People went to what they thought was Amazon.com, and the site looked just like Amazon.com. People went and bought whatever. They put their credit card information in, and they hit submit. Never got anything because it actually went to the bad guy. They collected a lot of money that way. So if you're on a site, like for example, I do buy things from the internet, but I only go to certain sites that I trust, that I've used before. I don't use a lot of sites that I'm not familiar with. And one thing that you need to do is you need to look at if you're supposed to be at Amazon.com and you look up at the address and it's not Amazon.com, that's a bogus site. If you're supposed to be at, Microsoft has been hit with this. So if it's supposed to be MSN, you should actually look at the URL. And we don't really think about that because we're on the internet, we're going all over the place. We don't think as much about security as doing whatever we want to do, go and find out the weather or go and buy something. But because we don't think about it, that's how these attacks take place. You go somewhere that looks familiar and you just assume it's the place where you think you are, but really it's a whole nother server that's collecting information on you. So there's a lot of different ways of gathering information. You could get pop-ups, or you can get some type of message, and then you say okay, and what happens is something's downloading on your system and it's gathering information that may be pushed back to the attacker. We had, a whole storm of emails that came supposedly from different banks and different merchants, and the text always said, you need to click on this and update your information or your account's going to be suspended. And in the beginning, this really started a couple years ago. In the beginning, a lot of people fell for it and gave up account numbers, social security numbers. But we had so many of them happen, people got wise. So we don't get as many of those emails. Now, what's the problem with identity theft? People have gone through hell trying to recover from this type of attack, because if somebody ruins your credit, there's 3 different credit bureaus that have this information. It takes forever to be able to correct that. Sometimes, people have actually gone to buy a house and they couldn't get it because they found out somebody's been using their identity. And you can't usually clean it up very quickly. It takes a long time to track this down and communicate with the banks and all of this. If you go through this, sometimes it takes up to 3 years to get your credit and to get everything back to normal. So another way that data has been collected for a lot of years, it's called dumpster diving. And we don't really think about necessarily everything we throw away. And people have been getting information from trash for a long time. Even the cops have done it to get information about some suspect. And we actually cover this a little bit more in the legal section, because there's this whole thing about dumpster diving isn't illegal, but you could be trespassing. So if the actual trash can is like on the public street, or if it gets put into the actual dump truck, then it's open to the public. But we'll go into that more in that domain. But for now, this is where identity management or identity theft happens also. It's not just digital, because companies, throw away a lot of information that could be used against them. Users do it all the time. And that's why, more and more people are buying shredders. You need to know what you're throwing away and what could be used against you. And these aren't really, this isn't CISSP, but just so you know that identity theft attacks are evolving. They have evolved. It's not just through email where it says you have to change your account information, because people wise up and that doesn't work as much. Now people are calling and actually calling you and saying this is your bank, and will ask you for your social security number, or there'll be an automated thing that said you won some type of prize. You just have to type in your social security number and then you can get your prize. So these types of attacks are evolving as people are wising up to the previous ones. Now, another issue that can come into play with identity management or identity theft is spyware. And now the CISSP exam, if you look at the actual domains and what they have listed, in this course I've actually moved a few things around. We cover everything and more, but just because, like, I moved spyware here because it really there's a connection with the identity theft. And then we'll actually cover a lot of viruses and Trojan horse and worms and all of that together when we get into application security. So spyware, what is this? Well, for a while we had this thing called adware, which meant that merchants would collect your information. They'd actually download and collect your browsing habits and use that to get you to buy something quickly. So for example, let's say that I go to Amazon.com. I'm going to buy this book that's written by this really cool chick about CISSP, and once, I'll purchase that or maybe some other security books. Now, Amazon.com could put that in a cookie and put it on my system, so the next time I go to their website, what are they going to show me first? Security books, so I could hurry up and spend my money and buy something quickly. So adware is something that actually gets downloaded and gathers information on people who are doing shopping, and there really wasn't anything malicious about that. And then the attackers figured out, hey, this is a way in. And we don't want marketing data. Spyware usually collects some type of sensitive data, social security numbers or online banking information or something. In the first domain, I talked about that our overall hacking has changed. There's been a whole evolution of hacking where it used to be just people having fun. It was challenging. A lot of hackers did it so that they could brag to one another. And now the hackers are much more organized. It's a lot of organized crime that's involved. It's much more towards profit. It's not for bragging rights anymore. So the people who are carrying out a lot of the attacks now are trying to fly under the radar, and they have specific targets. In the past, hackers used to, and they still do a little bit, but they'll scan the whole network and find, maybe SQL service running because they have an exploit for that. They don't care whose SQL database it is. They just want to exploit it because it's fun. Now hackers will pick a specific target and go after that specific target because they know somehow they could benefit from it. And they are staying under the radar, and this is one reason that viruses are they have already started going away. Viruses that used to spread throughout your email, your contacts, that's really a thing of the past, because those viruses, it didn't help the virus writer, it just spread a bunch of malicious software. It didn't help them. Now the attackers are doing things that isn't just going to spread and do nothing for them. They're going to have attacks that are directed, organized. Some of these groups are unbelievably organized and are all about profit or attacking another country. So spyware could be used, which means that somehow something's going to get installed on your system. It could be through an attachment on an email. It could be some type of a pop-up that comes onto your system. It could be any kind of message, really, and they look real. That's how people get fooled. They actually look real, and they could be, it says you can get a free screensaver, or that you can. What was really common is it says your system has been compromised by spyware. Download this spyware tool and we'll clean it up. And if you say okay and download it, it really is spyware. Now spyware means that it's on your system, it's just sitting there, and it could do a whole bunch of different things. It depends on what the payload is. Gather information, it could destroy data, but the whole goal is to get something on your system. Now another thing I don't know that the CISSP is getting into yet, but a lot of times when an attacker wants to download some type of software, it's called a bot. So they're going to use your computer in a whole botnet network to attack others. So there's a lot of different ways to get software installed on somebody's system. When something is being installed that your computer, your operating system recognizes, you usually have a very common pop-up that says, something's digitally signed, something's not digitally signed. But things like spyware, it happens in the background, and you don't necessarily get a message that you know what's going on. And just like other types of attacks, new spyware comes out, maybe 2, 3 a week, And the same with viruses and other types of malware. And so really, I mean, somebody who works for me in my company, they did their signature update on their antivirus. They did a full scan on Monday. They got whacked on Wednesday because something brand new came out. And so, you know, a lot of times people just will scan their system maybe once a week or once every 2 weeks. But as often as new stuff comes out, it may need to happen more quickly. So there's different types. You know, spyware comes in a lot of different forms to fool people. You know, there's some type of toolbar that has some functionality. There's you know, a lot of things says they're anti-spyware programs, screensavers. So there's a lot of ways that they come up with novel and new ideas to get you to get this malicious software on your computer. So, you know, what do we need to do? We're always, you know, you're not supposed to open attachments from people you don't know. Your email browser or your email client should not accept HTML graphics. HTML is a markup language that can have malicious commands within it. And so that's why a lot of people don't accept HTML to come down into their email. They actually won't, it won't show up. Like that's when you get the, where there's supposed to be a graphic, it's just a little X box because it could be something dangerous. It doesn't allow that to come down. If you get a message that wants you to click on a URL, it's better to, instead of clicking on that URL, because that could be a bogus, it could say msn.com and in no way is it. So you should take that URL and actually put it into the browser yourself. So there's a lot of things that we can do, and within an organization there's a lot of products that are going to do content filtering and antivirus and all this stuff to look for this type of malicious software. Now we're going to go into single sign-on technologies, and I mentioned and talked a little bit about them when we were going over identity management, but now we're going to go into the specific types of technologies that can be used. Now, in the industry, there's actually a lot of different types of products that provide a single sign-on capability. For the exam, we need to know what ISC² has listed as single sign-on solutions, which is directory services, security domains, thin clients, Kerberos, and Sesame. And so we're going to go through each one of those. But I know, and you may know, that there's other single sign-on products that provide this type of functionality. But this is for the exam. This is what the information we need to know. So single sign-on, again, it's all about just having to provide one credential set. The user doesn't have to remember all these passwords to be able to do their job and get access to the resources they need. And like I said before, the security issue is that if I only have to remember one credential set, then the attacker only needs to compromise one credential set and get access to everything, which is called keys to the kingdom. So, you know, we've got to weigh. Every organization has to weigh if they need a single sign-on, if it's the best for them or not. So a single sign-on, you know, it has much more efficient logon. If your users have to have 4, 6, 8 passwords, this is a more efficient way to go. Users can be, the user management can happen a lot easier since all of the accounts will be in one place. Then they can be, you can administrate them, you can maintenance them, and then if a user, you know, leaves the company or somebody gets fired, then it's only one place you have to get rid of that account, and not all of these other accounts throughout the whole organization. You don't need multiple passwords, and the goal is that now, since the users only have to remember one, it'll be a large, complex password. So it provides central administration. So those are the good things. And again, we talked about the security issue. And one other thing is that to have a single sign-on environment is kind of a utopia.
most environments you have maybe 80–85% of your resources that can plug in and be controlled by the single sign-on. But then you have legacy systems and legacy applications that can't communicate that way, and they have to be dealt with their management software. And the same thing is true for a lot of the identity management things that we talked about. There's legacy types of application or proprietary applications or legacy devices that don't always fit into the identity management protocols and software. So the first single sign-on technology we'll look at is directory services. And a directory service is something that works within a directory or within a database. So basically you have a database. They usually follow the X500 standard, and that's accessed through LDAP. And then you have the directory service. The directory service is managing all the objects listed in the directory. So it'll be managing the users and the resources and permissions and maybe certificates. So the directory service is managing all the user and resource information, and it's also network aware. It's a network aware service, which means that it knows and understands and communicates to the network devices and applications. So how is it single sign-on? Well, you only have to authenticate to the directory service. Active Directory is one of the most common ones people know. Users authenticate to a domain controller. The actual directory service is called Active Directory. When you send over your credentials, it has a user database and with your credentials in it. Once you're authenticated, then it's going to allow you to access other resources. You don't have to log in to access the file server and the print server, everything. It all happens through the directory service. I said that a lot of products are combining, and because identity management, all these needs are taking place: provisioning, auditing, user management. So even the directory services are having more and more of these types of identity management services that we talked about earlier. Now, a security domain is another single sign-on approach that ISC² defines. And what is a domain? Well, the word domain has actually been around a lot longer than Microsoft, even though that's what people usually think of as a domain, like a network domain. But a domain just means that these are the resources that a subject can access. And when we look at operating systems, we'll see that processes themselves have domains, which means what they can access within the software. So a domain just means what are the objects that the subject can have access to. And a security domain means that one domain is actually administered by a single person or a group with a single security policy. So it could be a directory service that's enforcing the security policy, or it could be some other type of technology. But a security domain means that you have one group of objects that is under one security policy, and each one of those devices are enforcing that. You of course can have more than one domain, and then you have trusts that can be set up between them. So you can have a domain, an internal trusted domain. You can have maybe a domain for your partners that you have less trust with, and it's all based on trust on the amount, how authentication is going to take place between them. So I may be able to authenticate to one domain and hop over to another domain if there's a trust relationship and if I have authentication to do that. So somebody with a higher trust level, a user with a higher trust level, can usually access more than one domain or more resources. And that makes a lot of sense, is that the more you're trusted as an individual, the higher maybe your role has a lot more privileges, and you can access more resources and more domains than somebody who is less trusted and maybe just a user. Now, another technology that ISC² puts out as a single sign-on is thin clients or dumb terminals. Now, dumb terminals were used a long time ago. They connected to the mainframe. And I talked about mainframes in the first domain, that's where all the processing took place. And then they connected these terminals, these dumb terminals, where processing actually wasn't taking place on these terminals. It just allowed users to interconnect or connect and do time sharing and use the mainframe. Now we don't really use dumb terminals as much as we use thin clients. And thin clients means that the client itself doesn't have the full functioning capability. Maybe it doesn't have the full operating system on itself, but it's on a server that it's using. So it's interesting, within the history of computing, we started with the mainframe, then we went to the dumb terminals, then we went to PCs, and now we're kind of going back to centralizing our applications and our processing power, and how we're doing that is using these thin clients. So if I had a thin client, let's say that it seems as though the application or the operating system is running on my system. It seems when I'm typing, I can't even tell, unless there's some type of latency, I can't tell that the processing is actually happening on a server. So how is it a single sign-on? Well, I can only do what that server allows me to do. That server is the one that does the authentication, and it will allow me to make access requests to the different resources. So it's a single sign-on in that I just have to authenticate to that server, and then it will allow me to access other resources, and I don't have to log in. It'll authenticate me on my behalf. Now, Kerberos is another single sign-on technology, and we're actually going to go deeper into Kerberos because you can get questions on Kerberos that ask about specific pieces and parts of it. So Kerberos is one of the technologies I cover to more of a depth than the other single sign-on technologies. Kerberos has been around for a long time. It was mainly used in the Unix world for authentication. It's based on symmetric cryptography. Now, if that doesn't mean anything to you right now, we will get into that when we hit the cryptography domain. But that is something you need to know. The characteristic of Kerberos is it's based on symmetric cryptography, and we'll look at how that works. So what are the main components within Kerberos? Well, we need to have a KDC, which is a key distribution center. That's the server that has all of the users' accounts, their ID, their credential sets. So it's an authentication server, but it has everybody's keys. And some people get confused when we talk about keys in Kerberos. And really, you could think of a key as a password, because a lot of times a password is used as a key. Because if you think about it, a password is really just broken down into a binary value, and a key is just binary value. So, and we'll talk a little bit more about that. But so there's a KDC that has all of the keys, and we don't use the word like users and services in Kerberos. We say principals. And principals are the users and the services. It's anything that has to authenticate to the KDC. Those are called principals. Now, the KDC is responsible for a realm, and a realm is a set of principals. If you're, it's like a domain. You can think of it as kind of like a domain. One domain controller is responsible for all of these resources. So these are the main components we need to know about the KDC, The principals are the ones that are going to use the KDC by authentication, and then collectively they're called a realm. So a KDC can be responsible for one or more realms. It doesn't have to be just one. It can be responsible for more than one realm. Now within the KDC itself, there's two main services that we have to understand. There's an authentication service and there's a ticket granting service. The authentication service is where the users, the principals, are going to send over their credential information to get authenticated. And then the ticket granting service is going to allow for these users to be able to communicate to other network devices. So let's see how this takes place. Within a KDC, we have an authentication service, and we have a ticket granting service, a TGS. Within the KDC, again, that's where all the principals' credentials are. Now, in an environment that is using Kerberos, a principal cannot talk directly to a principal. So I cannot just send over a print job to a print server. I have to go through this whole authentication process. No principals, they don't trust each other, so they can't directly communicate. So what happens is I come in 8 o'clock in the morning, I sit down at my workstation, I put in my username and password. My username gets sent over to the authentication service. Not my password, my username. But I have typed in my username and password, and I don't really know what's going on in the background. So I type in my username and password. My username goes over to the authentication service on the KDC. Now the authentication service looks in its user account database, says, is there Sean Harris? Yes. And it looks up my key, my secret key. It will take my secret key and it will encrypt a ticket. It will encrypt a ticket called the TGT. Now, when it gets to my system, if I've typed in the right password, that password is used to decrypt that ticket, and now I'm authenticated to my system. So again, I come in 8 o'clock in the morning, I type in my username and password, my username goes over to the authentication service. If I'm in the database, it gets my key, my secret key, and a ticket is created that's encrypted with my secret key. It goes over to my workstation. My password is cached because I've already typed it in. If I typed in the right password that is used as the key, it will decrypt that ticket, and now I'm authenticated to the system. Now I can get on my system, do my files, but I can't go and talk to any network resources yet. I've just authenticated to my system. So when I want to talk to another principal on the network, I have to go and communicate with the TGS. And basically what happens is I send over a ticket to the TGS and to prove that I've already been authenticated. Basically, I send over this ticket to the TGS and say, look, I've already been authenticated. I need to talk to the print server. There's a lot more information to it, just like everything. We're going 1 inch deep on every subject. So the TGS will validate that ticket that I send over. And what the TGS is going to do is create another ticket. Once it's validated my ticket, it's going to create another ticket. Within that ticket, there's going to be 2 session keys. So really 2 instances of the same key. Now, what's the difference between a secret key and a session key? Well, a secret key is one that's static. You'll use it over and over again. It's just like your password. You'll use your password over and over again until you change it. That's what a secret key is. A session key is only good for 1 session. So once a session key is used, it's destroyed and it's not used anymore. So again, I have authenticated to the KDC. It sent over encrypted ticket. I put in my right password. It decrypted a ticket. Now I need to communicate to the print server. I send over a ticket to the TGS and say, look, I've already been authenticated. Now I want to talk to the print server. TGS is going to create another ticket. It has 2 session keys in this ticket. Now one key is encrypted with my secret key, and the other session key is encrypted with the other principal secret key. So we have one session key that's encrypted with my secret key, and we have another session key that's encrypted with the print server's secret key. So this ticket will come to me. I will use my secret key to decrypt and extract that session key. Remember that my secret key could be my password, and it's already cached. I've already typed in my password, so it's cached. So my secret key, my password, is used to decrypt and extract a session key. Now I send that ticket over to the principal I want to communicate with, the print server. The print server does the same thing. It takes its secret key, decrypts, and extracts the session key. Now, what has gone on so far is that the print server knows that a trusted entity is vouching for me. I can't directly talk to the print server because it doesn't trust me. All the principals trust the KDC, so when I send a ticket over the KDC and say, hey, I need to talk to the print server, the KDC is going to make a ticket that is one of the keys is going to be encrypted with the print server's secret key. If the print server can properly decrypt and extract that session key, that means it came from the KDC. Only the KDC and the principal have a copy of their secret key. So far what this has proven is that this ticket actually came from the trusted source, the KDC, because nobody else should have the secret key of the print server. So one more time, I authenticate and I'm on my system. Once I need to communicate outside to the network, I will send a ticket over to the TGS, and the TGS will make another ticket. Now, I said that the ticket contains 2 session keys. Remember, session keys are only good for one session. One session key is encrypted with my secret key. The other session key is encrypted with the other principal's secret key. Now there's one more piece that actually goes into this ticket. It's called the authenticator. The authenticator comes from the KDC. It has identity information about me. You know, this message is coming from Sean Harris. And it has sequence number and a timestamp, and it's called the authenticator. Now you see the authenticator is encrypted with the print server's secret key. Now, when the ticket comes to me, I do what I said before, which is I take my secret key and I decrypt and I extract the session key. Now I'm going to add information to that authenticator. I'm going to say this is from Sean Harris, and then I'm going to encrypt it with my session key that I just pulled out. So what we have is that I told the KDC, look, I need to do a print job. I need to communicate with the print server. It created, the KDC, the TGS service that's on the KDC, created a ticket with 2 instances of the same session key. One's encrypted with my secret key, one's encrypted with the other principal's secret key, and it also put this information that's called the authenticator, and it encrypted it with the print server's secret key. I got the ticket, I used my secret key to extract the session key, then I put some information in the authenticator, basically, you know, this is Sean Harris, and I encrypted it with the session key. Now the ticket, just like I said before, goes over to the print server. It uses its secret key to extract that session key. If it can actually extract that session key, it knows that it came from the KDC. Now it needs to know that I am who I said I am. And it's going to use that session key that it just extracted, decrypt the authenticator information, and read what I put in there. So like, let's say it says Sean Harris. Then it's going to use its secret key and decrypt what the KDC put in there, and it's going to compare the two. If the KDC says this is coming from Sean Harris and I say this is Sean Harris, the KDC is vouching for my identity, and now the print server will take my print job. These steps are usually pretty confusing to people who aren't familiar with Kerberos, how it takes place. And we don't necessarily, know that it's going on because we log in and we access the necessary resources. But Kerberos is, quite popular. It's the default authentication protocol for Windows. It's been used in Unix for a long time, so it's been around. But a lot of people don't understand necessarily the steps. Now, for the exam, you'll need to know KDC, TGS, TGT, principles, realm. You can get a question on what the authenticator is. What is that for? And in the authenticator, like I said, there's like a sequence number and a timestamp to ensure that there's no replay attacks. That means that somebody can't grab that ticket and submit it and act as though they're me and authenticate to that other principal as myself. The Kerberos is an open protocol, which means that different vendors can take the protocol and manipulate it as they wish. So they can get the code and they can manipulate it to work within their servers, their environment. So that's why we actually have different flavors of Kerberos, and not all versions of Kerberos are interoperable, because the vendors modify them for their specific products. So we've covered the authenticators it's used for authentication, and we need to know why we're even using Kerberos, because a lot of people in my classes, when I go through all of these steps, they seem very complex, and I get a lot of questions of why do all of this? And in reality, this is how a lot of protocols are working in the background. Again, this is single sign-on technology. Remember that I had signed on one time. I put my username and password in once, and I didn't have to authenticate again. There was tickets being granted to me, to my system, that allowed me to communicate with other principals. So that's why we're talking about it. It's a single sign-on technology. And those tickets have a lifetime. Like when I authenticate to the authentication service, the ticket that comes back to me has a lifetime that the network administrator sets, which is usually about 8 to 10 hours, because that's how long somebody's going to be at work. So those tickets have lifetimes. The second ticket is only used during that session. So if I need to print something else, let's say 10 minutes later, I have to go through all those steps again. Get a ticket from the TGS, do the whole session key, authenticator dance. So those are created for each session that principals need to communicate. So that, again, when I go through this, a lot of people think it's nuts, why go through all of this just to be able to print something. But there's just as much confusion or just as much complexity to any other type of authentication protocol. We just usually don't know what's happening in the background. We usually could just log on and do our work and not really understand the complexity that's going on under the covers. So the thing about the using this Kerberos protocol is because the principals don't trust each other, and they only trust the KDC. And when we go through cryptography and we're going to look at PKI, it's the same type of thing. People don't trust each other directly, but they trust the certificate authority. So there's one trusted entity that is vouching for the identity of the principals. When I need to talk to the print server, the KDC is trusted. The print server trusts the KDC, so the KDC basically gives me this note, this ticket that says, hey, she's okay, go ahead and allow her to print. So it's a trust thing that's set up that the principals aren't going to trust each other. It's only the KDC, and if the KDC says that this is Sean Harris and she can print, then the print server will allow it to take place. So there's some things that we need to know about Kerberos. It can be a single point of failure. If the Kerberos server goes down, the KDC goes down, then nobody could do any communication on the network. So there needs to be some type of redundancy or fault tolerance in place. Also, the keys are stored on the workstation, and these are the kind of questions you could see on the CISSP exam, like what is a downfall or a fault or a security issue with Kerberos? And one of the answers could be that the keys, the session keys or the secret keys, are stored on the user's workstation. But that's true for anything that uses keys. So it's not just Kerberos. You have to store the keys somewhere. But that is one thing that could be listed on one of the weaknesses or vulnerabilities of Kerberos. So what did I say that Kerberos is based on? What type of cryptography? It's symmetric. It doesn't use asymmetric, it uses symmetric. So that KDC also must be hardened because it's the one that has all of the keys for all the principals. That's what the attacker would like to get access to. Now, Kerberos is vulnerable to password guessing, and let's look at how that would take place. When I log in, my username goes over to the KDC. What the KDC sends back is an encrypted ticket. Now, at my workstation, I could put in password after password after password to try to decrypt that ticket. Kerberos doesn't know anything about that type of attack, and it doesn't provide any type of security for that. But the operating system does. That's where you configure how many failed login attempts you'll allow. So if Kerberos is being used in an environment, it doesn't mean the whole environment is weak and open to password guessing. It's just that that protocol is an authentication protocol, and it doesn't cover that piece. Another piece of software has to take control and deal with that issue. And all of the principles, all of the software that's being used for authentication has to be Kerberized. And that means it has to have software that can actually understand this whole ticket and key business. So, like I said, not everything usually can fit in a single sign-on environment. You'll have some type of legacy systems that don't understand Kerberos, so it can't use that for authentication. Now, something very similar to Kerberos is called Sesame. People usually aren't as familiar with this technology, but it really provides exactly the same type of functionality. It's a single sign-on technology, but where Kerberos is based on symmetric cryptography, Sesame uses both symmetric and asymmetric cryptography. And we'll look at how that comes into place. It doesn't use tickets, but it uses privilege attribute certificates. So Sesame goes through the exact same steps as Kerberos. I log in, and instead of communicating with a KDC, I'm communicating with an authentication server. Now, that authentication server, once I am authenticated, will allow me to communicate to not a TGS, but an authentication attribute server. So it's the same kind of functionality, but they use different labels. And it's not tickets that are going back and forth. It's called PACs, Privilege Attribute Certificates. And where the authentication or the asymmetric cryptography comes in is that there's digital signatures on the communication that's going back and forth. So you have to have asymmetric cryptography to be able to carry out digital signatures. And that's the main difference between Kerberos and Sesame, is that Sesame is actually using digital signatures to validate who just sent it some information. So if you're not familiar with digital signatures, that's something we will cover in cryptography. So Sesame, same thing as Kerberos really, but it uses asymmetric cryptography, and it calls the same types of components that carry out basically the same type of functionality, different names, like the privilege attribute server instead of the TGS, a PAC, a privilege attribute certificate instead of a ticket. Now the reason that Sesame was even created was to deal with or overcome some of the what was seen as security issues with Kerberos. The goal was if you integrate asymmetric and require digital signatures at each point, that provides more security, more authentication between the components that are communicating. But Sesame never, it didn't really win the war. Kerberos won the war. That's what's used most in most environments. Now, like I said, that Kerberos is an open protocol, and that means that vendors can change it however they need to. They can change the code to work with their products, integrate within the environments. And so what like Microsoft has done has taken Kerberos and taken some pieces of Sesame, and they actually kind of combine the two, where there's a PKI involved. Now, for the CISSP exam, you don't need to know about combining Kerberos and Sesame. What you need to know about is Kerberos. It's based on symmetric cryptography. There's a KDC. It has authentication service and ticket granting service. Tickets are used for authentication. Principals use the tickets for authentication. It's a single sign-on technology, and it's vulnerable to password guessing, and it could be a single point of failure. The same things actually are true about Sesame. Sesame too is vulnerable to password guessing, but again, it's not that it's vulnerable to it. It just that doesn't go into the realm of what it covers. Now we're going to look at access control models. And first I want to explain about what an access control model is before we just dive into them. It's a structure that an operating system or an application uses to determine how subjects and objects interact, how access is actually controlled. And it is the core of the operating system. So it's built into the code in the actual kernel, and it's not something that could be manipulated. So a model, an access control model, is built so that the subjects are controlled and what types of objects they can access and what type of operations they can carry out. Now the different types of models we'll look at is DAC, MAC, role-based, rule-based, and access control matrix. We're going to go through each one of those types of technologies. Now, discretionary access control is really the most commonly used in the industry, and we use it all the time, we just don't realize it. A DAC model means that the user can be a data owner, and the user, as the data owner, can decide who has access to the resources on that system. So if you, on your system, you create a file, you could share it out, and you determine who can have access to it or not. It's discretionary. It's up to the data owner's discretion on who has access to those. And that doesn't provide as much security as another model we're going to look at. Also, DAC systems are called user-directed. It means that authentication access requests are being based on the identity of the user. That could be like Sean Harris as an identity, or it could be a group or role. So it's identity-based access control decisions. Now, how DAC enforces its security policy is through access control lists. And when I say security policy, I don't mean the organizational security policy. Sometimes people get that mixed up. We covered in Domain 1 that you have an organization or a security policy that actually describes how the whole security program should be set up. But each device, operating system, application, they also have their own security policies, which is different. It's the type or the level of protection that they are to provide. So when I say that DAC, that's discretionary access control, it enforces its security policy, that means the level of protection it's supposed to provide. It enforces that through ACLs, access control lists. So when I go to try to access a file, basically my identity is going to go over and to the object. The object has access control lists on it, on the object, and it'll say who could do what. If, Sean Harris is listed, and it'll say Sean Harris can read, so that's all I could do. But if I'm not listed, I can't access that object or do anything with it. So DAC systems use ACL to enforce their security policy. Now, the permissions that are used within DAC systems are ones that we're probably familiar with: read, write, execute, change, delete. Those are the type of operations that are allowed for subjects to carry out on objects. Now, a DAC, something that's working with a DAC model, works on a need-to-know basis. And basically what this means is it's least privilege. You should only give access to somebody who actually has a need-to-know, like you created a folder. Only give access to who actually needs to get in there for their work. But it's actually an informal need-to-know. When we look at what's used mainly in the government, that's more of a formal need-to-know. So you could see on the exam, what is a characteristic of a DAC system. It would be need to know, and what that means is only allow access to whoever should have it, not to the whole world. Now, of course, we have a lot of different security issues. But with DAC systems specifically, one of the problems is that malicious code can download and run in the security context of the user. So let's say I'm logged in, I'm an administrator on my workstation. If I have spyware or some type of Trojan horse, I download some type of malicious code, that is going to work as an administrative security context because I'm an administrator. So that's what the bad guy wants. The bad guy wants as much privilege access as possible because then they can access more resources and do more damage. And this is why the new Microsoft operating system doesn't make users automatically like administrators. They're trying to reduce the security context of the basic users, so you have to configure for more privilege. And it has to do with this issue where you get malware downloaded, and it'll do whatever you could do, access any type of resources or carry out any type of operations. So DAC is different than Mac. It's not Macintosh, but it's a mandatory access control model. Now, a lot of people aren't familiar with these types of systems. We are familiar with DAC because DAC is, every Windows system is based on DAC, Linux, Unix, all the systems that most people are used to is based on the DAC model, which means it has within its security kernel how it makes its access decisions is the data owner will determine who can access the resources, and it's based on identity. Remember, DAC is the access control decisions are based on identity. Now, when you're using a system that's based on the MAC model, this is a very secured system. And you as a user, you can't just share out any type of file or folder. You really can't do anything as a user. You could just use the system. You can't change configurations. It's a very locked down system. And these are only used where there's secrets, that have to be protected. So in a lot of government agencies, and some government contract companies have MAC systems. But they're not very common. They're hard to work with. They take a lot of administration because users can't do anything. And they're not user identity directed. That means that access is not based on just just Sean Harris. It's based on a formal need to know and a classification and a clearance. Because the user is actually assigned a clearance. Like if you've been in the military or if you're familiar with how that works, if you get a top secret clearance for like the government, the United States DoD, they're going to do a 7-year background check on you. They're going to go talk to different parts of your family, people who've known you, your friends, and they have to figure out what type of person you are to be trusted to be able to access top secret information. And so the user, the subject, is assigned the clearance. Now the object has the classification. The object can be classified as top secret, secret, confidential. So it's not, when I'm on a Mac system and I want to access a file, it won't be just Sean Harris can write to this file. It will be, who are you, Sean Harris? What is your clearance? Let's say it's top secret, and it'll look at the object, and the object is top secret, so the clearance and the classification match. And then I also have to have a formal need to know. Because if you think about it, if I have a top secret clearance in the Air Force, does that mean I can access all top secret information in the Air Force? Absolutely not. Data is compartmentalized, so it's somebody way higher than I decides what I can access, and it's based on my need to know what my job is within the military or the government. So a MAC system will look at the identity, and it'll compare the labels. The subjects and the objects have the labels. The subject has the clearance, the object has a classification. So it will, if I have a need to know, if my clearance maps to the classification and my identity, then I'm allowed to access the object. Now, MAC systems are based on a model that we're going to talk about in another domain, the Bell-LaPadula model, and it's actually a formal model. And what this means is that a formal model can actually be proven mathematically. So there's a lot of different vendors that create mandatory access systems. It's not just from one vendor. But there's a model that indicates how you could build software, an operating system, that will use these labels for its access decisions. So most of them are based on a formal model, and then the vendor uses that model to follow to build the software, and then it understands the requirements of the user, the security requirements, and that's how they're going to determine how to build that software. Now, another type of technology that's used in environments where mandatory access control systems would be used is called a guard. And it could be a piece of software or a dedicated hardware device, and it's controlling how different classification data is going back and forth. Basically, if you have a MAC system that's holding top secret information, that system has a high trust level, a high assurance level. Now you have other systems that doesn't have as high of trust or high assurance level. Do you want those systems to be able to directly communicate with this server that has the highest assurance level holding the top secrets for the nation? No.
So there's got to be something that's actually understanding and controlling that type of communication.
So a guard will basically sit in the middle between different systems that have different classification levels. So if this one server has top secret, and let's say another server has only secret, when it tries to make an access, it has to go through the guard. The guard has rules already set up of what type of information can come through. It may sanitize the data, it may not allow it. And so if it does allow it, then it goes to the top secret system. And usually the top secret system isn't going to be communicating back. The only thing that usually comes back is an acknowledgement of receipt. So you can have a Mac system and have DAC systems and other Mac systems. You don't want them directly to communicate with your server that has such important secrets. And then so that's where the guards come in. They will look at the data, go by their rules, and determine if this type of information can go to that server.
So I said that DAC is really what we're most familiar with. We just don't use that terminology usually. That's our Windows, Linux, Unix. Most systems are based on the DAC model. If you as a user can give permission to somebody else, or you can add somebody to a file and say they can read or write or whatever, that's a DAC system. In a Mac system, there's no way that a user has such privileges and rights. A user can't do anything. It's very locked down. And that's because they're holding such sensitive information.
Now, one Mac mandatory access control system that is out in the corporate world is SE Linux. They took the NSA and Secure Computing took a version of Linux and really locked down the kernel and the whole system. So it works on like classification and clearance mapping. The other types of systems, we don't really know too much about them, and that's how the government likes it. So a DAC system enforces its security policies through ACLs. A Mac system enforces its access decisions on labels. So that's important to know. And what are the two parts of the label? The two parts are the two parts are classification, because the object has a classification. The other part is called category, and that's the need to know. It's a category. So if I'm a user and I'm trying to access a file, the file will have a label on it. And in my profile, it will have my clearance level. Let's say my clearance is classification match. Then there's a category, and a lot of times within that category there could be maybe a few categories. And if in my profile lists the same category, that means I do have I have a formal need to know to get to that information. So DAC is identity-based, user identity-based, and MAC is based on clearance, classification, need to know, and labels. Now, another model that people are usually more familiar with this terminology is role-based access control model. And that just means that you're setting up some type of a container, a role or a group, and then you're assigning permissions, rights to this container. And then you put the user in the container. So you assign users to groups or assign users to a role, and they inherit those rights.
Now, role-based access control is best used like in environments where there's a high turnover of employees because it reduces the amount of administration. Where you just create a role, and somebody works, you put them in there, they're going to leave. The next person, you just put them in the same role. Instead of having to assign these rights specifically to Joe, and then Joe leaves, take those away, and assign it specifically to Susan, take those away. So role-based access control was developed specifically to make administration a lot easier with user management.
Now, a lot of people don't know all of the functionality within the formal model of the role-based access control model. And actually, I just recently wrote a paper for Information Security Magazine on role-based access control and how it plays in identity management. And the exam isn't going to get very deep into role-based access control, but it's becoming more important in the environment because we're having to control access to our assets. It's very difficult to do it just by users. You know, you could have 3,000 users, and how do you know what individual users have to have access to? It's a lot easier to know what role, you know, if this person is going to be doing backups, this is what they should have access to. That's a lot easier. So more and more companies are setting up role-based access control models. Now you could set up one that is in a hierarchy, and what that means is that one role will inherit all the permissions and rights from the ones below it. So for example, let's say there's in a hospital, there's a lab technician. He can only have access to certain information in the database. The nurse, she can have a little bit more access, and she inherits what the lab technician can access. And then there's the doctor. The doctor inherits all those permissions, and then he has some on top of that. That's how the hierarchy actually works. Now, role-based is also being used for separation of duties. And I told you you're going to see this in a few of the domains. And it's very difficult to actually implement separation of duties properly. But if you have a critical task and you split it up that this role does this part and this role does the other part, that's a lot easier to control than saying, you know, Joe does this and Bob does this. You set up roles, and it doesn't matter who you're plugging into. So you split up the critical task and assign the roles to only be able to carry out a component or a part of that task, and then another role has to finish it. Now, access can be assigned explicitly. That means directly to the user. So if I'm going to assign you read and write, that's explicit because it's based on your identity. The other way that a user gets rights would be through they would inherit it, and that's what I talked about with the role-based access control. It's not tied to an identity, it's tied to an actual role. So there's a difference between implicit and explicit. Explicit is that the rights are assigned directly to the user. Implicit means that the user inherits the rights, and it's usually inheriting from some type of a role. Now, another model is called rule-based access control. And really, it's just like it sounds. There's just a whole list of rules that are being used before access is allowed. The most traditional and common rule-based access control is a firewall. A firewall has a whole bunch of rules. When a packet comes in, the packet is compared to these rules to determine on if it can go into the environment or not. And it doesn't matter about the identity. It's not looking at a user identity. Another example is, let's say the administrator sets up email accounts and only allows a certain attachment size to come in through, through other email accounts. It can only be a certain size. It doesn't matter who you are. It's a rule that goes across the board. Now, rules are used in other places. They're being used more and more, like in content filtering. When some type of traffic comes from the internet into your environment, you usually have a content filter that's looking for, pornographic stuff or words like confidential or things that are not supposed to get through. And basically, it just has a bunch of rules. Another way that it's being used now is we have this whole data leakage problem where sensitive data is getting out of environments. And that's usually because users are emailing it out or FTPing it out, or they don't understand. They don't know how to contain and properly treat sensitive information. So the sensitive information a lot of times is leaving the perimeter. So we have new type of technology that basically has a whole bunch of rules. So when an email is going, it goes to a device and it's compared to all these rules to make sure it doesn't say confidential or top secret, or there's specific keywords. And if it doesn't match any of those, then the email can go out. But that's an example of rule-based access. So again, a firewall is what most people are familiar with. It's a whole set of rules, especially with packet filtering, which we're going to talk about the different types of firewalls when we go through network security. So the last access control model we'll look at is access control matrix. And this is very simplistic, and actually the DAC model uses a matrix like this. And in the matrix, we have rows that are we have columns that that's the objects, and then we have rows that are matched to the capability of the user. So if you go through the top of the matrix, at the very top, these are the objects, like file 1, file 2, file 3. And what's connected to that object, let's say file 1, what's connected there is at ACL, just like I talked about. Who could do what? Who could read? Who has full control? So the object has an ACL connected to it. The user has a capability table. So a user has like a profile, which can be called a capability table, indicating what that user can do with the resources. So if, let's say on a Windows environment, when you log in, a profile comes down from the domain controller, and it dictates what your working environment is. Maybe you can't change the system time, maybe you can't work as administrator, but you can access this and you can access that. That profile is your capability table because it indicates what you as a subject can do. So capability tables, they can be like a profile, they could be a ticket, like we talked about in Kerberos. Tickets can indicate what you can and can't do. It's just the user or the subject's capability. What can they carry out? And a lot of these, of course, are configurable. Your profile is configurable by the administrator. In Kerberos, what you can and can't do is configurable by the network administrator. Now, another type of access, and this is somewhat new to the exam, but it's temporal access, and that's based on dates and times. So you can lock down, or you could set a rule that says that Joe can only access the files in the database Monday through Friday, 8 to 5. So that means if Joe or somebody's using an account that's Joe's account is trying to access over the weekend, that's not normal. There could be something going on there. So temporal access has to do with dates and time. Another example could be if were hired after this date, you can't have access to these files that were created previously. That's another example. So up to now, we've talked about identification, authentication. We went through several authentication technologies: passwords, biometrics, smart cards. We talked about identity management and all the technologies that fall under that umbrella. We went through the models, DAC, MAC, role-based. And now we're going to talk about how access control is administered. How are we going to control all of this stuff? Who could do what? And our choices really are centralized, decentralized, or a combination of the two. So a centralized access control method is just like it sounds. You have one group who is controlling who can access what. And so, for example, you have a domain controller that is enforcing a specific security policy, and everybody within that domain is being, the access is being administered centrally that way. And you have decentralized, which we'll talk about, which just means that everybody's like doing their own thing. It's kind of a peer-to-peer approach. So centralized is the most common in most environments, because you really want one group making the decisions, configuring the technologies to determine who can access what, and they should all be following under the same security policy. And this allows for more standardization, so everybody has the rights that they need. If it's decentralized and people can come up with their own access permissions or decide on different rights, then it's not a consistent and standardized approach to administration. Now, you could also monitor, and you can have uniform processes of assigning, setting up user accounts and setting permissions and taking them away. So there's several technologies that allow for centralized administration. On the CISSP exam, they look at specific remote centralized administration technology. And what we'll cover is radius, TACX+, and diameter. Now, all of these are referred to as AAA protocols: authentication, authorization, and auditing. That means that these protocols carry out all of those functions. Now, it could say, the last one could say auditing, or it could say accounting. Even in the industry, that last A is commonly changed out, because it's really not just auditing. A lot of people think, well, yeah, it's just keeping track of who's doing what. But that's how, like, service providers charge customers. Like corporate accounts has, going through a service provider for some type of access to the internet. Well, they're going to be charged based on the bandwidth that they actually use. So the auditing or the accounting piece really is used more by service providers when they have to calculate how much bandwidth has been used on how much is going to be charged to the customer. We as users don't get into that realm as much, and that's why a lot of people think auditing means it's creating logs. So the first technology we'll talk about is radius. It's been around for a long time. It'll be around for a long time, and it's used to authenticate remote users. And the most common place these are used is for, like, ISPs. When you need to log in and get access to the internet, you have to pay an ISP. You're going to send your credentials to a radius client, and that radius client is going to take your information and send it to a radius server. So radius works on a client-server model. Now, you as a user is not a client. You send in your credentials, and there's a radius client. The radius client doesn't do the authentication. It just takes your information and it passes it back to the radius server that actually has the user database of all the users and the credentials. So your authentication and your access request just goes through the radius client, passes it off to the server validates your credentials, and then sends accept or deny back to the client, which means you can or cannot get onto the internet. Now, when the radius client communicates with the server, it could be sending other information, not just access. Sometimes when let's say I make a request to access, my request goes to the radius client, and my credentials and requests go back to the server. Now the server, it'll send over, yeah, she can get on the internet, she's been properly authenticated, or no. But it also could send over information like how much bandwidth I'm allowed to use, or if some type of a VPN or something needs to be set up. So it's not just yay or nay if you can get onto the internet. Now, Radius isn't only used in ISPs. They're also used in the corporate environment. So if I need to log into my corporate network, I'm going to go through an ISP, and I'm going to get authenticated that way. Now I'm on the internet. Then I'm going to go to my corporate remote access server that's using Radius, and I have to authenticate again. There's another Radius client there that communicates to a Radius server with the database. So it's not just for ISPs, it's used in corporate environments also. Now, TACACS Plus provides basically the same type of functionality as Radius. And TACACS has actually gone through several generations. It was TACACS, and then it was X-TACACS, which is extended TACACS, and now we're at TACACS Plus. So it just goes through different generations and more features and functionality. Now, a big difference between TACACS Plus and Radius is that with Radius you don't have a lot of configuration control as an administrator. You can't get very specific on what the users can or can't access. In TACACS Plus, we have the authentication, authorization, and auditing features actually separated. So the administrator could choose to only use one or two of those pieces. In Radius, you get them all 3 A's. In TACACS, they could be split up. So maybe you only want to do authentication, and you have another piece that will do the authorization, another technology. And also it allows you to create much more detail-oriented profiles. So instead of just saying, yes, the user can be authenticated to the corporate network, the TACACS Plus profile can be much more specific, saying the user can have access to this and that. So it just gives you more granular control over your access administration. Now, Diameter is a new protocol that it doesn't seem a lot of people are very familiar with it yet. It's a replacement for Radius. And Radius is actually an acronym. It stands for, something. Diameter, the people who came up with that name, they have a terrible sense of humor because they came up with diameter because they say it's twice radius. Radius, radius, diameter. That's where it came from. So that it's not an acronym for anything. So it's a built-on, or it's basically a new and improved Radius. And Radius has some limitations. It can only be used in SLIP or PPP connections. So we're going to talk a little bit more about what SLIP and PPP is in network security. But basically it's an encapsulation protocol that goes over telecommunication connections. So Radius was set up because that's how computers communicated. They went over some type of telecommunication link. And Radius only can authenticate people through the traditional ways, PAP, CHAP, EAP. Again, we're going to hit really those a little bit deeper in another domain, but those are very traditional ways, usually based on passwords of how you get authenticated. So now we keep having all this different type of technology that is going to use different protocols, needs to authenticate differently. Maybe some devices don't have like a full TCP/IP stack, so they can't authenticate this way. They're not going over PPP connection. So we needed a way to be able to authenticate other types of devices that are going to go over other types of protocols and require different authentication methods. So that's why Diameter was actually created. And it's being slowly pushed out, but it's not going to replace Radius totally. Radius will be at the ISPs because the ISPs don't necessarily need all the functionality of Diameter. Diameter is only going to be used like in corporate environments that have several different needs for different types of authentication.
Well, in our environment, we have we have wireless laptops, we have PDAs, we have smartphones.
Eventually, not right now, we're not really, the PDAs and the smartphones aren't authenticating to the network, but eventually it's probably going to happen. And those don't necessarily have, a full TCP/IP stack, and they can't authenticate over the regular way, and plus they're not going to necessarily go over a PPP connection. So we have different wireless technologies. We have voice over IP, voice going over our network. That those telephones need to be able to authenticate, which isn't going to happen over radius. You have mobile IP devices. So there's a lot of different technologies that require authentication and not over the traditional ways. Now, I mentioned mobile IP, and that's not necessarily a part of a diameter. It's just that diameter will support authentication for something that is using mobile IP. And what mobile IP means is that you can go from like one network to another network and not have to log in again. Basically, you can log in at one network, you get your IP address, you get your subnet and all your network configuration information, and then you go, let's say you take your wireless device and you go to over to another network. Well, what happens is that your information is sent over. You have a home IP address that's been assigned to you, and then when you move, there's basically information that says this person's been authenticated and they need one of your addresses because it's going to be a new network, so it's going to have its own IP address space. So when I go over to this other network, what I'm going to get is care of address. So that means that that's the address I use in that network, but I have an IP address in my own network. So that's basically mobile IP, very, in a very simple terms. So it allows devices to be moved around without having to reset your configuration, network configuration, and authentication. So diameter works in, you could actually see it, one resource says it works in a peer-to-peer architecture. Another one says it does a server and a client architecture. Now, Radius and TACACS work in the traditional client-server architecture. You've got a component, even with TACACS, you have a TACACS client that is going to take the request from whoever wants to log in and is going to get the authentication information and pass it back to the TACACS server that has the user database that will make the decision. So it's just like a Radius. So that's the traditional client-server model. In Diameter, it uses a peer-to-peer connection in that the different Diameter software is going to communicate directly. So it's like with the mobile IP, if I'm in one network and I'm authenticated to a Diameter, through Diameter to a specific authentication server, and I go over to another network, that authentication server will talk to the one over in the other network and say, hey, she's authenticated and here's her information, so I don't have to re-authenticate. So that's how it works in a peer-to-peer. It'll work in a client server only that that when you have to authenticate, then you're the client. So how does Diameter provide all of this different type of functionality than Radius? Well, it's based on how the protocol itself is built. The protocol has a base protocol, which means this is how the authentication components are going to take place. But really, you could do a lot of different types of authentication. You could do the regular traditional PAP, CHAP, EAP. You could use PKI, Kerberos. So the Diameter base protocol will be controlling how the authentication happens. And then there's actually extensions. The extensions are what allow the other types of technologies basically to plug into the diameter. So there's an extension for mobile IP. There's an extension for voice, so that those types of technologies have a way, an interface to be able to communicate with the diameter authentication protocol. Now, the extension of the functionality is really based on the attribute value pairs. And it's not just the diameter protocol that uses these attribute value pairs. If you think about how a protocol works, a protocol is used for standardized communication between like two systems, any protocol. And you could think of it like a piece of paper with lines drawn, so you have some boxes. So let's say I have a piece of paper with 12 boxes. Now in those boxes, I've defined what type of values can go in these boxes. So in box 1, I can have, maybe a 1 or a 0. Box 2, I need to have a certain type of flag. So I have this piece of paper with this box, and when I send over the piece of paper to you fill in those boxes with whatever the empty variables are. So you take your information, you put it in those boxes, and you send it back, and then I interpret it. That's how all protocols work. They basically have a structure that says, this is the type of information I need. It goes over to the other computer. That computer puts that information in. It comes back, and then that information is read. So depending upon how many boxes you have will depend upon how much functionality that could take place. So where Kerberos really has it works off an 8-bit model, diameter works off a 32-bit model. And what that means is it has a lot more boxes, which means you can have a lot different types of communication. And so it has boxes that can understand EAP, digital certificates, Kerberos, where the Radius protocol didn't have all those boxes. It only had boxes for PAP and CHAP and EAP. Diameter has basically boxes to understand voice over IP and mobile IP, where Radius didn't have that in its protocol. So that's how diameter has more functionality, because it works on a protocol that has a higher bit. It's a 32-bit model, and it has all of these what's called attribute value pairs. And that just means that it has in a box a specific label, and then the receiver is going to fill in that empty variable of what that information is. Now, I don't know that the CISSP exam is not going to get that deep into what exactly an attribute value pair is, but you could see that term and you wouldn't know what it actually meant. So what you need to know about diameter is that it is a centralized access control administration protocol. It is a successor to Radius. It has two parts to its protocol. It's got a base protocol, and then it's got extensions, which will allow the different types of technologies to use it. And it works on a peer-to-peer model. Those are the basic types of information you would need to know. So we covered 3 types of protocols that are used for centralized access control administration. That is Radius, TACACS+, and Diameter. And they are referred to as AAA protocols: authentication, authorization, and auditing. So there are other types of technologies that provide centralized access control, but really that's what the CISSP is going to cover. Now, the other choice is to have a decentralized administration. And this could be, that you just have peer-to-peer workstations, and you don't have some type of an access controller or a domain controller making the decisions. Or
a lot of large organizations have like the corporate head, they have their corporate environment, they have the different offices all throughout, maybe even the world. And in that situation, at one office, they will have centralized access control there. They'll control how access controls within their environment. Then another one will do theirs, and another one will do theirs. They're not all connected. So that's one example, too, of how a decentralized access administration could take place. They're not all centrally connected. So again, a big issue with that is that access control isn't taking place in a standardized method.
So there's other ways of controlling access to information. These aren't too difficult. We're pretty familiar with those. Like a kiosk system, like in a public environment, you can go and interact with a system, maybe an ATM machine. You're actually reduced to the amount of operations you can carry out based on what's presented to you. And what's presented to you is an environment with only a few buttons. So like an ATM, that operating system can do a lot more than just allow for withdrawals or deposits or show your account. That operating system can do more, but there's an access control, a physical access control piece in place where you only can interact and carry out these operations based on the buttons that are presented to you. Another way to carry out access control is database views. And we are going to go into databases and look at these again, but right now we need to know that database views is a type of access control. What that means is it's a logical way of controlling who could see what within a database. So, I could have lower access than you. Let's say I access a database and I can only see 3 records. You access the exact same database and you can access 10 records. It's based on the database view, which is configured by the database administrator. So other ways of controlling access would be like a profile that we talked about, setting up what a user can and can't do. There's a lot of different ways that are used within the models that we talked about to control what subjects can do with objects.
Now we need to make sure that our logs are protected. And earlier in this domain I talked about accountability, and it's becoming more and more important within industry and in the exam. The exam is covering accountability more. And that's because we've got regulations that are coming down that are forcing the big guys, senior management, to be accountable, so they're going to make sure everybody else is accountable below them. Now, why do we have to protect these logs? They're just full of, just mundane information. Well, they're really not. I mean, there is a lot of information within logs, but there is some critical information about who access different objects. And the reason that we have to protect the logs is because that's one thing that most hackers will go in and try to modify. So let's say I've hacked into your system, and I've done whatever. I've installed a backdoor, and I've took some of your sensitive data. Now those activities are in the logs. They could be an application log, or they could be an operating system log. Now I don't want anybody to know that I did it, so I'll go in and I'll scrub the log. That means I'll take out the entries that shows what I did. So that's why we have to protect logs. Within the system itself, we protect them by assigning the right permissions. Like, nobody should really have write permissions to logs. They can have read permission to logs. So within the application, or within the operating system, they're usually protected through permissions. Now, when you store logs, when you store them outside of the computer, we usually protect their integrity through some type of a hashing algorithm, which we'll get more into hashing algorithms in cryptography.
So there's you know, the logs, we are getting more and more logs all the time. That's because we're putting more and more types of technology within our environments, and everything's keeping track of what's going on, which is a good thing, except that it's overwhelming. So that's why we have like event generation, or you take all of your logs into one type of product, and it's going to have rules to indicate, you know, this is what needs to show, this is what needs to show, you know, we need to flag this, and so that somebody doesn't have to go through all the information in the logs, because usually there's a lot of mundane information there.
Now we're going to go into intrusion detection systems and intrusion protection systems. So intrusion detection has been around for quite some time. It's going to look for some type of attacks or suspicious activity. We're going to go into the different types of IDSs that are used on the market today. But there's two main types, network or host-based. So if it's a network IDS, that means that it's watching all the traffic on the network itself. It could be on a system with a NIC, network card, that's in promiscuous mode. And what that means is usually when we have a network card on our system, it's only looking for our address, our MAC address, and any type of broadcast and potentially multicast traffic that's coming our way. If a network card is in promiscuous mode, that means it's going to see all the traffic, which an IDS obviously has to do to be able to determine if there's malicious code. Now, there's one thing that IDS we have problems with in switched environments, and most of our environments are switched, meaning that we use switches more instead of routers and bridges and such, because switches are much more, we could do VLANs, and it happens very quickly. We're going to go into VLANs and switches and telecommunication. But the problem with IDSs in a switched environment is the IDS really is just a sniffer. It's a basic sniffer which is watching the traffic that's going through. Now, in a switched environment, you have specific communication paths between a port to port. And a sniffer can't sniff or understand and watch every single port. So in a switched environment, what we have to do is we have to take all of those ports and mirror them and basically make one big port that's mirroring all the traffic that's going through. And then you have a sensor on that mirrored port so that we can make sure that the sensor is actually watching all the traffic that's going back and forth. So with IDS, what happens is that it's going to, if there's an attack that takes place, it's going to get those packets, and a lot of times there's more than one packet that's going to carry out some type of attack. So it will gather the packets, and it uses an engine to reassemble the packets so it could determine, yes, this is an attack. And it's going to verify it against either signatures or a behavioral profile that we'll get into. And then it's going to, however it's configured, whatever the actions it's supposed to take, it will log it. It could send a message to the router or the firewall to reconfigure itself to stop that type of communication into our environment, or it may block the session by sending FIN packets if it's over a TCP/IP, or if it's using TCP. So then once there's some type of attack that's identified, it's going to go to the console, and it's going to probably email the administrator or whoever's responsible for looking at this, or it may actually go out to, if you have like a managed service, then all that information goes to the service that's managing this, and then they will be involved in helping the company take care of this issue. So the question is, where are you going to put the sensors? Well, there's no traffic is going to be analyzed on a network unless you have a sensor there. So you can have a lot of different subnets within your network, and the sensor's only going to be able to see the traffic of individual subnets or segments. So companies a lot of times are going to put a sensor within their DMZ, because their DMZ is where potential attacks are going to come in through the firewall. Now, some companies decide to put a sensor outside their firewall. And why would they do that? Well, they would put a sensor outside their firewall just basically to see who's knocking, what type of things are hitting and not getting through necessarily. But when you put it outside your firewall, you're gathering a lot of data to see, maybe predict some type of attack that could take place. So if you see, if that sensor sees scans, IP scans, and it sees some port scans, it could have this information together, and you can deduce that there's probably going to be an attack within 3 days, because that's how it goes. Once you see a scan on the IP addresses, port scan, then at least within 3 days there's going to be some type of attack. So if the sensor's outside the firewall, that's because they want to gather a lot of information about potentially what can take place. But a lot of companies just put the sensor behind the firewall because they're just concerned about what actually got in, what got through our firewall. Because when you put it outside the firewall, it's going to gather so much information because there's so many things going on the internet. There's so many scans, there's so many attackers trying several different things, so it's going to gather a lot of data. Now, where a network IDS is looking at the traffic, of course, on the network, we have host IDSs, and its whole world is just within the system, what's taking place within that computer. It doesn't look at network traffic, it doesn't even know that network traffic exists. So when you have a host IDS, the administrator is going to configure some type of security policy, and that security policy is going to be pushed down to the server or the workstation, wherever you're going to put your host IDS. And most environments don't have host IDSs on all systems because that's a lot and it's hard to manage. Host IDSs are usually used on critical servers, so you know if something's actually taking place on a system that's critical in nature. So the host IDS usually has like an agent that's sitting there on the system, and it's watching for suspicious activity, it's watching for unusual behavior by the user, it's doing a lot of things, but the main thing it does is it's looking at the logs. Because a system makes a lot of logs from application, operating system, and it continually looks at the logs to see if there's anything suspicious, and through its security policy, that's how it defines what something is suspicious or not. And in a lot of environments, we use both. We use the host IDS on the critical servers, and then for the network sensors, we have them placed in our critical areas. Not necessarily through the whole network, although you can do that. It's expensive. You have to buy all the sensors and put them on all the different network segments. But you're covering everything. So in a combination, you're seeing everything. You'll be able to track what's going on in the critical systems, what's going on in the traffic, and specific products that have this combination will then give you more of a unified view through a console, management console, of what's going on in the environment. Because there could be something that's going on over here, and that's what you go and look at, but really there's something more important going over here. So if you have a unified view, you see the big picture, and because an attacker could be coming in through different ways. And we're going to look at some ways that what attackers do, but sometimes they'll cause a big stink. They'll do a denial of service on one system, so everybody goes to that system and tries to fix it and figure out what's going on, but the real attack is actually taking place on another system, so they're just making everybody busy with something that's not as important so that they won't be noticed when they go do the serious attack. So there's two main types of IDSs. It's either signature-based or behavioral-based. And signature-based just means that signature used just like in antivirus software. So when, let's say it's on a network, it's a network sensor, it's going to look at each packet and it's going to have a signature of all of the known attacks. So there's an engine on the sensor that's going to get the packets, compare it to the signatures in the database, and see if there's a match. If there's a match, then it determines there's an attack, and then it does whatever it's configured to do. Log it, alert administrator, reset a firewall. So that's signature-based. Now, behavioral-based doesn't use signatures. What happens is you take this IDS and you put it in a learning mode. And basically, it just learns what's normal on your environment. The traffic, the types of traffic, the types of protocol, the user behavior. It just learns over like usually a 2 or 3 week time period on what's normal in your environment. And then it creates this profile. Once you take it out of learning mode, it creates a profile. And then it'll have sensors to look at all the traffic, if it's network-based, it'll look at all the traffic, and anything that doesn't match this profile will be considered an attack. So because of how they work, they usually have more false positives, or I'm sorry, false negatives, because anything abnormal, it doesn't necessarily mean it's really an attack. It just doesn't match what was captured during those 2 weeks of the learning mode. So the signature base can actually detect just the attacks that we know about, known attacks, because the vendor had to write the signature. So that's how it's definitely known. Now, a signature base cannot detect an unknown attack because it doesn't have a signature or pattern to map it to. Behavioral base can detect new attacks because it's not basing its decision on these signatures. So it can detect actual zero-day attacks where signature-based IDSs cannot.
Well, if you look at an actual packet, we have headers, we have TCP headers and IP headers, UDP headers, and it can look for things that are unusual. Let's say a Xmas attack. This is kind of an older attack. But if you look at a TCP header, there's all these different flags like SYN, FIN, urgent, push. There's all these different flags that are used between systems when they communicate. Now, for no reason, all these flags should not be turned on. They only should be like one at a time because it's used for communication. I could do set FIN flag to 1, and that tells the distant system that we're finished. But if there's no practical reason for all of those to be turned to 1, all of those flags to be on. So that's an example of a signature. That's what would be in a database, is looking for a TCP header with all of those flags turned from 0 to 1. So if the sensor picks up a packet with that type of signature, then it'll know that there's an attack going on. And another example of a signature would be to be able to capture land attacks. And a land attack is when the sender manipulates the IP header so that the source and destination IP addresses are the same. So if I want to carry out this type of attack to your system, what I'm going to do is I'm going to manipulate the packet header and have the source address, which should be my computer address, but I'm going to have the source address to be yours. So in the packet, the destination address, which is your address, and the source address, which is now your address also, is coming over to your computer. And computers that are vulnerable to this type of attack, they just don't understand. They don't understand because they're not written to have these addresses be the same. So, but that's an example of a signature. There would be the sensor would have a database, and it will be looking for if the IP addresses are exactly the same. Then there's an attack. That's a land attack.
So I said one of the types of the IDS is behavioral based. And what's interesting is if you know the history of this type of technology, that's the type we started with. IDS was built within the government to be able to watch for not attacks, but users misusing resources. So when the first one was built, it was mainly to watch the government employees using a specific system to make sure they weren't doing stuff that they weren't supposed to be doing. And then that technology grew and was integrated within more of the security industry, so we're looking for specific attacks. Now, like I said, in the behavioral base, you're actually going to put the product in a learning mode, and it's going to understand or listen and watch all the different types of protocols that are coming through: TCP, UDP, ICMP, routing protocols, and it'll create this profile. Now, one thing you need to make sure is that there's no attack going on when you're building this profile, which has happened. So if you are, let's say you have this in learning mode, and actually you have a system that's going under attack, the IDS is going to capture that and consider that normal. So whenever this attack or this type of attack happens again, you won't be alerted because it's in the profile as a normal thing. So that's one thing to understand, is when you're putting it into a learning mode, that nothing suspicious is taking place on the network at the time. Now, something else that behavioral-based can do is detect the attacks that are trying to stay under the radar. You know, a lot of attacks are very noisy, and that's because you use specific tools. You're doing things that IDSs should be able to detect. You know, the fragment attacks that we'll look at, or ping of death, or denial of service, or these things are very what's called noisy because they bring attention to themselves. And then there's other attacks that are very quiet, that stay under the radar. And I've done assessments where we had to look. Basically, the customer didn't know that we were carrying out an assessment, and we were testing not only being able to break into the environment, but we were also testing the security team, their reaction to certain type of anomalies or situations that were taking place on their network. So in those types, it's called a stealth attack or stealth assessment. And so you send like one packet at a time, or maybe a couple packets at a time. It's very slow and it takes a long time, but you're going under the radar. And that's what a lot of attackers are trying to do right now, is, of course, not get caught by the IDS. So this is something that the behavioral may be able to detect compared to a signature-based IDS. So signature-based is pretty straightforward. It's just like I said with the antivirus. You have a whole database of signatures. You have to constantly update these because new attacks are coming out all the time. So where the signature base is pretty straightforward, the behavioral base, which is looking for anomalies, is not as straightforward. And that's why it causes a lot of mistakes. You know, it throws up flags, it says that there's some type of attack, and it's really not an attack. So where we came from using only behavioral-based IDS, the industry has then moved to using signature IDS, and now what we're doing is we're combining them. Although the exam won't talk about combining these types of IDS products, in the real world, a lot of them are combining the way that they're doing it to try to make sure they address all or find all the types of attacks there. So, you know, it could be on the anomaly base, it could be statistically based, meaning that you set thresholds, or when it captures what's normal in your environment, it will set thresholds itself. So, for example, if you had 10 FTP requests in 10 minutes, that's not that big of a deal. That could be normal. But if you had 50 FTP requests in 10 minutes, that's suspicious. Something's going on. So within the IDS, there's actual metrics, statistical metrics that are used with an algorithm to be able to determine what is normal and what's not normal, and it's based on this threshold. Now, another thing that behavioral IDSs can look at is a protocol anomaly. And what that means is protocols are supposed to react, the same way all the time. I mean, protocols are used so we can communicate to each other. And so they're supposed to all, be the same. If somebody's using TCP, TCP should look the same no matter where it is or who's using it. And what the protocol anomaly sensor will be looking for is when the protocol is not used as it's supposed to be. So if the flags, like I talked about, are there's values in there that there shouldn't be, maybe that you've got HTTP traffic going to port 25. That's not normal. HTTP usually goes to 80. SMTP goes to 25. Now, the protocol anomaly products are based on the RFCs that are created. These are the standards of how to create a protocol. And what makes it difficult is that if all the vendors followed the RFCs, then really all of the protocols would look and act the same. But a lot of vendors kind of manipulate the protocols to work within their environment, work with their products. So they're not all working exactly the same, which means if you're going to use a IDS that's looking at protocol anomaly, you're going to have to do a lot of tweaking. So I talked about a couple of attacks that really represent protocol anomaly. The land attack, where the sender and receiver IP addresses are the same, the Xmas attack, where all the flags are turned on. These are examples of protocol anomalies. Another one is like there's been different types of fragment attacks, and one's called the teardrop. It's an older attack, but basically what happens is when there's a packet that comes into your network, let's say, and it actually has to be split up into fragments. What an attacker will do is manipulate the offset, because when it gets to the destination, let's say it gets to your computer will take fragment 1 and fragment 2 and put them back together and be able to process that packet as one. But what it does is it uses the offset value that's in a header to know how to reassemble the packet. Well, in a teardrop attack, that offset is an incorrect value, and your system doesn't know what to do with it. It's not programmed to know what to do if the value is different than what is expected. So basically, your system's continuously trying to put these fragments of packets together, and the systems that are vulnerable could freeze or crash or something. So protocol analysis is, it's of course easier to carry out with the protocols that we use all the time, TCP, UDP, IP, ICMP. But when there's some type of unusual or special protocol, then you actually will have to do some tweaking so that it can understand exactly how that other protocol is working. And like I said, a lot of vendors don't actually follow the exact standard. And if you don't tweak or configure your IDS properly, then it's going to throw false negatives and false positives because it's not getting the right data. Now, another interesting thing is traffic anomaly. And traffic anomaly just means that you usually have traffic looks, maybe you have a certain bandwidth that's constant, or the type of protocols. But traffic anomaly is not looking at the actual headers or the data in the payloads of the packets. It's looking at what the patterns of the traffic is. And this is very common for, let's say, in the military units. You've got one military unit communicating to another unit, and of course the communication's encrypted. Now the attacker or whoever the enemy is going to watch that traffic that goes back and forth, and even though they can't decrypt, they'll keep trying to break the encryption of what's being used. But while they're trying to decrypt it, what they're going to do is they're going to watch that traffic, because when the traffic actually changes, you can infer that something may be happening. For example, if you have, let's say you have one military unit, and you have there's a bunch of military units, or let's say they're all over the place. Now the adversary is watching all of these different, these network or these communication channels. Now if you see a pattern of, from one of the units, there's a lot of data that gets pushed out to the other units, and then just a small amount come back to that main unit. So you have one unit that pushes a bunch of data out to the other units, and those other units only send a little bit of data back. That's one way to determine where the headquarters are, because that means like the headquarters are sending out orders to the other units, and the units will respond that they got the orders. So, that's just one example. And traffic anomaly is actually being used more and more today with trying to detect what the bad guys are doing. Now this is outside of CISSP, but what's really going on in the industry that not a lot of people understand is that we are all of these types of attacks that are taking place, a lot of times is the white noise. That means that the bad guys that are very organized will create tools that different people can carry out, distributed denial of service and all these other types of attacks. So they keep sending out attacks, and that's kind of the white noise. And the attackers who really know what they're doing will send very under the radar attacks. And so while the security professionals and the organization is busy with all of the white noise, the smaller issues, the smaller attacks, we miss the actual attack that's being very targeted. And so because this is happening, what's going on is trying to determine what the white noise is compared to the actual traffic that's really doing the damage. But that's again, that's out of that's not CISSP realm, but that's interesting of where we're going in the industry. So like I said, when the IDS actually sees that something's happening, it determines there's an attack, it can send an email to the administrator. If it's a smaller issue, it'll just log whatever happened. It can send a message to the router or firewall to reset, to close any traffic coming in from that IP address, which can be dangerous because attacks that come in a lot of times are using spoofed IP addresses. So if you actually configure your firewall to block a specific IP or IP range, you could be blocking legitimate traffic, and you're creating a denial of service on yourself. So you need to understand that a lot of attacks could be using spoofed IP addresses, and if you just cut off a connection or not allow that type of traffic into your environment, there could be legitimate systems that actually really use those IP addresses, and they're not able to get in and communicate with your systems. So this is usually, it's best, of course, if the sensors, the IDSs, are centrally managed. Like I said, you get a whole uniform look at what's going on within your environment. Some organizations today have it managed so that you're using like Qualys or something like that, so that the sensors are on the network and the organization itself is not keeping up with all the activity. They're paying somebody else to watch it. But one thing that's important to understand is that anytime you have any type of a managed service, you are not giving the risk over to anybody else. You can never get rid of your own risk. You can't hand it off. Unless you buy like insurance or something, that's when you're sharing risk with the insurance company. But when you get a managed service, if they don't do their job or if they miss something, you're not going to be able to blame them. It's your responsibility to know and check out how well they're doing, if they're doing the right job. And this comes into play with a lot of regulations. Regulations are requiring organizations to do some type of a security assessment on whoever they're using, whoever they're communicating with, managed services and suppliers and partners. So you can't pass on the risk, even though you could pass on the tasks or the functionality. So IDS, does that mean that's our silver bullet? That's all we need? Life's great? No, IDSs have, you know, kind of a hard time in the industry, mainly because it detects the attack after it's already taken place. So you don't know anything that's going on until you're in the thick of it. Also, it can't detect any type of attacks that are coming through an encrypted channel. So if you've got an attack happening over SSL or IPsec or PPTP, it's not going to be able to decrypt and get access to that data or those packets to be able to inspect them. Another thing is that a sensor can get overwhelmed on the network. If there's so much traffic, a sensor will actually not be monitoring all the packets. And that's actually done on purpose sometimes by the attacker, where they're going to overwhelm the IDS so that they hope that their actual attack packets won't be picked up. So because if it's a busy environment, companies can have a sensor that's looking for one type of these signatures, and you can have another sensor that's looking for a different set of signatures, and so that one sensor itself is not going to be overwhelmed. And I talked about the switching environment. IDSs are basically sniffers. When we have all of these switches set up, it can't watch the traffic on each and every individual communication path. So we have to create what we call like a mirrored port, so that that's where we place the sensor to be able to detect something. Now it's, you know, I don't know, it was a couple years ago that Gartner said IDS is dead. And a lot of people listen to Gartner, and a lot of the IDS companies freaked out because that means that people aren't going to buy their products anymore. But IDS works, but it's a frustrating thing because there's so many false positives. And a lot of companies have purchased IDS, implemented them, and then it throws out so many alerts, so many errors, that they just turn it off. They don't have the manpower to actually continually go and look at whatever's being generated. And because of that, the industry developed the IPS, the Intrusion Prevention System. And so instead of where IDS is after the fact, it says, hey, we're being attacked now, IPS will detect things before it gets in the environment to stop the attack. That's the goal, is to stop the attack. So an IPS really uses the same type of technology as an IDS. A lot of people say, well, isn't that just a firewall? Not necessarily, because most of them dig down deeper into an actual packet than a firewall. And you usually have an IPS and a firewall that either work together or they actually come together. The firewall will look at the traffic, make access decisions based on its rules, whether it's a packet filter, a stateful, whatever type of firewall it is. So it'll get rid of that, and then it goes to the IPS system, the intrusion prevention system, and that system will actually dig more into the packets to identify if there's anything malicious that's trying to come into the environment. So, it's IPS is kind of the new IDS, and the goal is to prevent instead of just detect. And we're at the market right now. We have to see how well it does. It's still kind of an immature technology, but we have to see how well it does and how much companies embrace it. So again, the difference is just before or after. And that the reason that Gartner said that IDS is dead is because it causes so many alerts, it takes so many man hours, and if once you're under attack, well, what do? Now you're in reactive mode versus being in proactive of trying to prevent that. So IDS itself, the actual sensors are vulnerable, and there's certain ways that attackers will find out if there's an IDS sensor on the network. And that's a lot of times, that's the first thing they want to figure out. Is there an IDS sensor on this part of the network that I want to attack? Because if there is, then I as an attacker know what type of attacks I can or can't do, or I want to overwhelm that IDS and be able to get past it. So I may carry out a distributed denial of service on the IDS to shut it down, so then I can go ahead and attack the system I want to. Now, another thing that is kind of interesting, it's called a padded cell. And I think in law we're actually going to cover honeynet systems, and a lot of people think that a padded cell and a honeynet or a honeypot system is the same, and not really. A padded cell means that there's code that's written in an application specifically to look for some type of malicious activity. So there's some type of triggers, because when you have whatever your software is, there's basic type of requests that are going to happen. It carries out its functionality, and there's actually code to look for suspicious requests or suspiciously formatted requests, which will act as a trigger. And once that trigger goes off, then the attacker is moved into a virtual machine that looks just like the environment, the same environment. So let's say I'm trying to get into your network, and I send in malicious or suspicious packets. This within the software will detect that, and it's going to move me, without me knowing it, into a virtual environment that looks just like the same environment, and I'm going to keep attacking and keep doing my things, and it's going to be recording all of my activities. So that's what's referred to as a padded cell. It's code that's embedded in a piece of software specifically to look for suspicious activity.